Hey Rick, good evening. Hey Stephen, good evening. Eric, Stephen, am I audible? Hey Stephen, Rick. Sean, am I audible?
Yes, I can hear you.
Fine. Okay, thank you.
How about Stephen and Eric?
Yep, I got you.
All right.
Okay. Hey Rick, good evening. Hey Stephen.
Hello.
Great. So we are back again for one more session. Okay. I know you spent some time with the books. So how was the journey? Was it good? Went to some chapters.
It's long, boring, and painful.
Okay, that's a very honest feedback. I know. That's why the PMP is famous. It will make you feel the pain. Yeah, it's kind of. Yeah, it takes little time. That's a primary reason we have the classes. These classes will give some highlight. So that's going to give more high level view of what we're going to learn through. Okay, what kind of thing you get out of when you read the book? Is it talking too much on tools and techniques? What actually you are learning out of it?
It's just a nice. It just works as a nice review session for what we discussed through the class. It's just a nice review session of everything. Kind of puts everything back.
That's my idea.
Second time through.
Yeah, hey, Eric, audio is good. Eric, I can hear you well. Thanks for that. Okay, yeah, got it, Stephen. That's valuable. Yeah, I know this one feedback keep coming on always. The PMBOK, whenever the people open the book, they feel dead sleepy.
Yeah.
So yeah, if you have any sleeping problem, then you open this book. Next few minutes will be.
Yep. Sleep like a baby.
Yeah. So the main point to take on is there is one other book called Rita Mulkai, and this book published from a Rita Institute. And this is a very famous book. I think it comes from Germany. And this book, I felt most of the candidates feeling good to read, as it shows more examples. This is one of the book I shared with Stephen and Eric over the Gmail G Drive. Right. So if you have downloaded that book, yeah, just take a look of it later point, where you will see a little more information than what we see in PMBOK, kind of. Okay. Yeah, saying that, so far what we did is we are in the journey of learning the project management processes. So the last three sessions, we have learned some of the basics of project management. We learned about how a organization look like, say portfolio management, program management, and project management. We saw the hierarchy of an organization. After understanding that, we also understood there is something called enterprise environmental factors, organizational process assets. These are some of the surroundings around us when we do the project. We can't do the project in an isolated way. We always have something around us, and these are the factors which we learn through, right? And then what we did is we also learned a project manager what all the capabilities this person should hold. Of course, it's a team effort, but still, as a project manager who is going to be leader of this group, should have certain principles and capabilities. And when we spoke about that, it was referring to the talent triangle, if you remember it well. The talent triangle talks about the talent triangle talks about primarily on the three factors. When you say three factors, it was talking about there was a triangle which talks about primarily on, as a business person, we as a person of a leader, we should have the business strategy in our mind, right? By the way, the screen is visible for both of you. Eric and Stephen, screen is visible.
Screen, yep, it's all good.
Fantastic. So we as a leader, being there as a manager, we should have the business strategy in mind. A project starts well only when a person has a business strategy in our mind. When this is there, we also have a technical skills with us, right? When I say technical skills, we know what this project all about and how to do this project effectively with the tools and techniques what we have. That's a technical skills should be have. And apart from the having technical skills, one other important thing a leader, a manager should hold is the leadership skill. Okay, the leadership skills. When we have these parameters equally distributed for a leader, and that makes a project manager a very effective person. And this is called as talent triangle. So the project manager will have these ingredients with altogether. That's going to make a best leader. And this we learn through in the first few chapters. So okay, after learning that, what we did, we started moving towards learning 5 processes. We understood that there are 5 processes, 10 knowledge areas, and 49 processes. This we learned through. And after which we get into the stakeholder management, we clearly understood that.
Oh, I just lost your audio.
Oh, is it better now?
Here we go. Yep.
Okay, good. Thank you. Now, we also understood that a project will go really well only when we have a clarity on the stakeholders. These stakeholders can be of internal person working in your team, or could be of external third party, or it could be of the person whom you are going to serve the product. So it is collectively a set of people, set of organizations who is going to get benefited out of this project or going to be affected by the project. We also saw some of the DAM example where we can also have a negative stakeholders. So we understood stakeholders are very important for the project. After understanding the stakeholders, what we did is we also understood the communication plan. Of course, there are people. When there is people, definitely communication should happen. But communication cannot be a haphazard communication. It should be very systematic communication. Why we need a systematic communication? As we have n number of people in this project, it is not going to be an easy job for you and me, being a manager or leader, where we can talk to everyone on everyday basis. It's highly impossible. So we should have a system in place. We should have a process in place telling that this particular stakeholder will be communicated on the frequency of every Friday. Another stakeholder will be communicated on every bi-weekly. So it is something we put a very systematic way of approaching the stakeholders. And these stakeholders will have a consistent touch of what's happening around, right? So, and that part we discussed in stakeholder and also communication management plan. Now, saying that, what I'm doing here is, okay, okay, here we go. Yeah. Right. So we understood the stakeholder part and the very important core part of starting with the project management. Then we understood on the part of communication management plan. This we understood. Stakeholder we understood. And then we traveled to the scope management. We are going in this order. It is because I want Stephen Eric to understand that stakeholder and communication are the lifeblood of a project. When these two are done really well, most of the project problem getting resolved. After which we understood, once we know who are the stakeholders, we talk to them to collect the requirements. This we did in the last session. We understood the requirement. Also, we understood something called as a WBS, which is nothing but work breakdown structure. We put the work into pieces. We use a tool called decomposition. That helps us to divide the work into pieces. When I say pieces, the manageable packages, we call it as work package. So what we learned today, what we learned the other day is we bring something called work package. We get some work package, okay, and we also have a work package dictionary, right? These two comes over, and these two is going to have some manageable size of work, and that's going to be given to the team to start the work. We understood that part here, and later in the game what we did, we also understood that the work will go to the team and team will do the work. After team does the work, it goes to quality department, and the quality department verifies and gives back to the validate scope. In validate scope, we do something called as UAT, that is user acceptance testing. It happens once this is completed, and this will be given to the close the project. So we understood this flow. Now, to do this effectively, we have to proceed on next stages. What are the next stages? I'll tell you. The next stage is going to be of schedule management. What is schedule management? And that's what we're going to learn today. In today's flow, we are going to learn how the time will be estimated, how the scheduling will be planned for this project. When I say for this project, in Create WBS, you have understood that there is something called a work package. A work package would be of a collection of activities. What is collection of activities? If there is a set of work to be completed, and that is going to be called as a module or a work package, which is under WBS. Now we take this one work package and we again further do decomposition, and we make it as activities. Activities is the lowest level of work which a resource or a couple of resources can do it. If in IT industry, in a database, they call it as database creation, they call it as web page creation. That is at the package level. When we go a little more down, it will be very specific on what need to be done. The more you specific you go down to the level, that will be called as activities. I'm going to show you a lot of information on that. For now, understand one thing, that we got the list of work what need to be done from the stakeholders, from the sponsors, from the end user. Once you do that, you have to do two more factors, which is called as schedule management and cost management. When you do that, what will happen is we are creating a triple constraint. If you remember really well, this is going to be do the triple constraint. The triple constraint, I keep saying, repeating it. It is going to be a triangle, and this triangle is going to have something called scope management going to be here, and you're going to have a schedule management, and you're going to have a cost management. So now what's happening here is this is called the triple constraint. Last session, what we did is we learned through the scope management. That's what we did here. That's called scope baseline. I was using a term called as baseline. Whenever you see something called baseline, it means it's an agreed upon deal between us and the key stakeholders, right? So that's called baseline. A baseline means something we agreed saying that, hey, this is what we're going to do. And when we say this is what, it is a mutual agreement between the sponsors, key stakeholders, end user, and the development team or the working team. The same way we're going to do for the schedule management. So let's get inside that. And before getting there, I'll give you just a heads up on in schedule management, we have first a plan. We're going to plan how this is scheduling going to happen. Whenever you see something called plan, it means it's going to explain how these factors are going to be done and how control is going to be done. And that will be explained in the plan. Now the question is why we have to explain that here. It is because the team and key stakeholders should be aware that this particular project will follow this particular way of schedule management, because there are a number of ways in the world. There are a lot of different methodologies in the world. We cannot just like that say that we'll follow a schedule plan. The stakeholder may not be happy. We should be very clear on what we are going to do. That should be documented. That should be explained to them. In fact, in plan schedule management, they even talk about what they mean by a work day. By the way, Stephen and Eric, what do we mean by a work day? One work day. How many hours it is?
That depends what industry you're in. Technically, it'd be 8 hours.
Yes, you're right.
8 hours.
Yeah, right. But imagine the same project comes from the country called Netherlands or coming from Norway. If I'm not wrong, that country has declared 6 hours as a work hours. If you're aware about it, the government of the country particularly has mentioned that 6 hours will be called as a man work day or a work hour. They're saying that 6 hours is sufficient enough for a person to work, not beyond that. If the policy says that, that should be clearly mentioned here. If not, what will happen is if you're doing a project for Netherlands or Norway and you give a billing timing as we will work 8 or 5 man days, they will consider 5 into 6 is going to be 30 hours in a week. But actually you would have worked 40 hours in a week. When you go for a billing, there will be a clash starts happening. So we should be very specific, writing down what we mean by the day. Day means 8 hours. And if any extra hour the team is going to work, that should be kept recorded here. And how we are going to record those information also should be mentioned here. I'll go deep inside. For now, understand that scheduling will record every inch of time related information. Right. So I'll go deep now. What I do. Yeah, we have it here. Okay, here we're going to have a schedule management. And today we'll try complete schedule management, and time permits will open a little bit on the quality management. And then the next day is going to be the cost and a little bit resource. After completing cost management, it's going to be lightweight. Up to this, it will be heavyweight as we have the subject is a heavy. After which it's going to be lightweight, we'll quickly move on, right? And a couple more and we'll be done for this week. I'm planning to make it happen within this week so that you'll be free for next week to start reading from the books. And we will start working towards the examination, right? Okay, schedule management plan. Okay, this is the 49 process sheet. Okay, and every chapter, I will have this first page talking about Agile methodology. To give a very short, quick look on Agile methodology, we call about adaptive environment. The adaptive environment is here, which talks about Agile and adaptive environment, where the idea here is we may not plan the project everything ahead. In a sense, you may not understand the scheduling factor of whole project at the first shot. Rather, we do step after step. When you get closer to the project, you get little more details. So it will be a progressive elaboration of identifying the timeline. To address a full delivery life cycle for larger enterprise-wide systems, a range of techniques utilizing a predictive approach, adaptive approach, or a hybrid of both may need to be adopted. I'll make it very clear here. You can use an approach what is feasible and good for the system. It can be predictive, it can be adaptive, or it can be hybrid. If you are aware, predictive means we know the requirement 100% clear and we do the work. Adaptive is we may not have full requirement with us, or the requirement can be changing consistently. So in that case, you go with the adaptive way. That is, you keep adjusting towards the needs. Hybrid is combination of predictive and adaptive. We keep moving towards, and we see nowadays most of the organization follow hybrid methodology. Here, the role of the manager, project manager, does not change based on the managing projects. See, just by the system changing, the manager role will not change. Whatever it is, manager role is going to be a little bit same. At the fact, it will be a little more high as well. And we have to be very flexible enough to accept any type of methodology. Point I want to make here is there is something called Agile Methodology, which says that you have to be good enough to do the adaptive way. You cannot say that I will collect every requirement, then only the project work will start. No, it may not work. So there is something called Agile method in PMP. Saying that, I'm starting with a process called plan schedule management. I'll read the key benefit first and then we'll tell you what it is. The key benefit of this process is that it provides guidance and direction on how. I will keep repeating again. Whenever you see the word plan, it means it's going to talk something about how factor. How the project schedule will be managed throughout the project. When I say throughout the project, it is from the first day of the project till the closing day of the project. We should know how it's going to be managed. And we'll write a plan for it. The plan is called schedule management plan. And in that plan, we need little bit clarity of what approach we are going to follow. When I say approach, it could be a predictive approach or it could be adaptive approach. Agile methodology. If I ask Eric, Eric will put over through saying I'm going to use Scrum. I will use iteration, 2 weeks once I'm going to deliver it. If I ask Stephen, Stephen will say that I will use a hybrid method. I want my customer to be happy. I will take approach whichever is good for me. So whatever approach we take, we will write it very clearly here, so that my customers will be very clear what kind of way the person is going to deliver me the product back. Is he or she going to deliver every week or every month or every other day is going to call me and confirm what is they going to deliver? Whatever it is, will be clarified, right? So that's very important. If you go for any online ordering, you'll know about it. Some organization, when you do online ordering, they keep sending you text message or email and keep on messaging and communicating to you. Whereas there are certain organizations, once you order it, once they'll send an email, after which only when you receive the product, you will get a message. Until then, there won't be any disturbance. It depends. Approach differs. But end of day, it should make customer feel good that you're delivering it. And if you remember, we did this scope management plan. That is how we are going to handle the requirement from start to end. And that is also being taken as an input. Why? Because we are doing scheduling part. The work we took will travel to multiple dimension or multiple weeks and months. We should know how this also should be managed. End of day, plan schedule will what it will do is it will take the approaches, it will take the high level charter details, it will take some of the two factors EEF and OPA, and it will use the experts in the market. And I'll tell you here, as a manager, you may not be able to judge everything on your own. So we have to take help of experts in the market in the planning phase to understand how a project planning will happen. They'll invite the SMEs in the market and they have the meetings, they do the analysis, and finally they come out with the plan. The plan is going to talk about how the project schedule will be managed throughout the project. It will be written down. If Eric is planning for an agile project, which is going to go for 6 months, you will have a plan in this 6 months, what will happen, how we are going to handle it. and that will be clearly mentioned here, right? And then if it is going to be a long-term project, and that will be properly given out with clarity. What will be the duration and what will be the ways we execute it? And this is going to be explained in plan schedule management. Is my audio good, Eric and Stephen?
It's good on my end.
Okay, fine. Okay, I will just explain a little more going forward. Okay, once you know the plan of a schedule, now the thing starts. When the thing starts, I want to just recall something like what we did yesterday. Yesterday we did something called, there was a work, there's a project. In the project we had certain activities, work packages. So we put a WBS like this, right? So we had a project, and the project had a work packages, work package, and I had one other work package, and we had one other work package, right? Now we stopped for WBS in this level, that is work package level. A work package which is a collection of activities, is what I was saying to you. Now we have to make this work package in a doable form. That's the next stage. The next stage we'll talk about making it as activities. A work package can have multiple activities. When I say multiple activities, it could be of granular level of work which the team has to do. Now we have to divide the work package into pieces. That's going to be called as activities. And that part will happen here in define activities. Now we take the scope baseline. If you remember really well, yesterday we talked about a scope baseline where it has 3 parameters. What are the 3 parameters we thought? Under scope baseline, we had certain things like we had work package, we had and then we had a work breakdown structure dictionary, and then we had a project scope statement, right? So we had work breakdown structure. We had WBS dictionary, we had scope statement. These 3 were prepared yesterday, and that's called as scope baseline. Now, when you have these 3 parameters as a scope baseline, and also you made a schedule management plan, how things are going to work on a time factor. Now we take this work package and start dividing into pieces, and we use a tool called as decomposition. If you remember really well, on the last day session, we used the same decomposition to divide a project into pieces, into work package. The same tool is going to be used here. Here the tool decomposition means a domain expert, a knowledge on the project will help a person to divide the work into pieces. If it is an IT industry, Eric will be a good person to divide the project into pieces of smaller work. If it is on other domains, where Stephen will be very expert on doing that, right? So now the decomposition is not a software. It is a thought process. It is an expertise, how you divide the work into pieces that is a smaller level. Now I'll tell you here, we took the scope baseline, that is the 3 factors here, and we'll start dividing into pieces using a tool decomposition. When you do that, you will get the list of activities. The list of activities is nothing but what you see here, 1, 2, 3. And like this, for every package, you'll get activities. Imagine a project, you have say 10 or 15 packages. Every package will have a bunch of activities. So endpoint is something collection of activities will become a work package. That's going to happen here. And this is the last most level. From here, the estimation is going to start. Now, define activities is plan to take a work package, use a decompose, and make it as activities. When you create activities, each activity will have one activity attribute. Each activity will have an activity attribute, which you see here.
Attribute means nothing but the collection of information for this particular activity. The same way, like WPS, we had something called WPS dictionary. If you remember it, we had WPS dictionary here, which is an information about this package. We had a dictionary here, if you remember it. Every package will have a dictionary. The same way, every activity will have attributes. In this attribute, it will be very clearly mentioned what is the time it will take to complete, who will do it, when they will do it, what is the dependency between this activity 1 and this activity 2. They call it as predecessor successor relationship. What will be the first, what will be the second. So we'll put an order, and that will also be explained there. So now what we have in our hand is we have a work package, and that work package has been divided into pieces. That's called activities, and each activity will have an attributes. Now the question comes from Eric and Stephen is, how do I divide into pieces? And this is a very $1,000,000 question. For that reason, they will have experts from the market. They'll invite the domain experts, the domain which you work. If it is a bullet train, they call the bullet train experts. If it is a software project, they call the software experts. If it is an infrastructure project, they'll call the infrastructure experts. So the domain knowledge is highly valuable here, where a person can divide the work into pieces to the lowest level. And it is called as hierarchical decomposition. When you say hierarchical decomposition, you start dividing pieces by hierarchy. It goes down. And that happens in defined activities, right? So I'll go to the next level. By the way, Eric and Stephen, are you understanding what is defined activities here?
Yes, I am.
Okay, very good. Thank you. Thanks for confirming.
Yep.
Yeah, great. When we do this defined activities, it is very important to know that not every package will have the clarity of information. In the sense, some will have information, some may not have information. So for that reason, we call something called rolling wave planning. A rolling wave planning here, it means when you don't have a clarity about the information, we will get the clarity as we get closer to that work. For example, if this package is all about an infrastructure and they know they have to make a foundation, then they have to raise a pillar of it. And they have to know that is this pillar going to be painted in a green color or it's going to be a gray color? They don't have a clarity. Only when you get closer to that work getting completed or moving forward to the government or the sector will give an idea, every bridge should be of a green color. Every bridge should be of a gray in color. So they give an instruction as they get closer to the work. And when you get closer to the work, the clarity is higher and that will be further divided and explained well. It is called progressive elaboration and also it is called rolling wave planning. To be very specific, at times we go to shopping mall or for purchase something. We may not know everything what we're going to do. As we enter the shopping mall, you get an idea. Oh, okay, I have to buy some more dress materials. I have to buy my shoes. And as you get to the shoe store, you will think, oh, not this time shoes. I'll go with sandals. I will wear something which is like this. So it keeps changing on until you get closer to the level. So some requirements which are not much clear in nature will go under rolling wave planning. When there is a high clarity of the work, that will be subdivided, that will be put as activities. So that's what happened here. Let me take the next level. I'm explaining here, rolling wave planning is an iterative planning technique in which the work to be accomplished in the near term is planned in detail, while work for further in the future is planned at a higher level. So certain things which you know clear, it's done now. If not, it's done at a higher level. And it's also called as progressive elaboration. You keep going on, right? And we also set the milestones. A milestone is a significant event that normally has no duration. Yeah. If a Toyota says us in this year we have to sell 1 million cars. So when they sell the 1 million cars, and that will be called as a milestone. But we cannot give an exact date that 1 million cars will be sold on December 31. No, you can't say that. It's about depends on the market need. So they will set a milestone. So same way in projects, we have certain milestones when this will be achieved. And that is important for the schedule management. I was talking about activity list, the list of activities for a project. Now, your WBS, work breakdown structure, it was divided into work packages. Now we took the work package and started putting into activities. I'll put things again. We had WBS and we have packages, and under package we're going to have the activities. Activities are last hanging fruit in your total tree, and that particular activity is written down here. If you watch out, these are the activities, and every package will have bunch of activities, and that activity will be list down here. If you see here, you see a WBS ID. If you see here, that's a WBS ID, which is nothing but the ID of this WBS. That ID is written here. Under this WBS ID, what is an activity? You'll start writing the activities. Each activity name and its description will be written here, and it's assigned with how many resources. This is all explained here. So like this, imagine if you're going to have a 10 or 15 WBS ID, and each WBS will have set of activities will be written down here. That's called activity list getting ready. So now once the activity list get ready, we have to move to the next level, which will talk about attributes. If I say it really well, you know that I was putting a diagram to say that is a work package. It's a work package. Under the work package, you have something called, you're going to have something called activities. So it could be of 1, it could be of here, it could be a 2, it could be of a 3, right? So now we have activities hanging under the each work package, right? This is how it's going to be activities, but each activities will have something called attributes. Attributes is attachment here. It's an attachment. Now what this attribute is going to have? It's going to have something very important information about the, what is going to have? It's going to have something very important here. It's going to have something like what you see here. It'll have, it belongs to which project, what is the date it's prepared on, and it'll also talk about predecessor and successor relationship. If you see here, you will have the predecessor, you will have the successor. What it means is this activity could be a predecessor and this activity could be a successor, right? For your PMP course now, your predecessor is the class, what you're learning now, and successor is going to be the examination. Only when you learn the subject, you can go for the examination. There is a dependency between both of us. Only when you read the PMBOK book, you can get ready for the examination. So these are some of the dependencies we have on that. At the same time, you can start reading the book even without the class. There are certain relationship, no need to be very mandatory. Without even you listening my session, you can start reading certain topic on your own. So there are activities which will have dependency, which may not have dependency. So this goes on predecessor and successor, and you write the relationship also, right? And also we have something called leads and lags. I'll explain more later on, which ideally talks about, do I need to wait for it or do I need to start even before something happens? And we talk about the type of effort we're going to put, location and assumptions, and these are the things which will be for each activity. If you see here, this attributes is for each activity. Each will have one. So that have more information. Now I'll come from the beginning. We had something called a project. From the project, we have good number of work packages. I took one work package, and that work package will have list of activities. And this is all done through a tool called Decomposition. The experts in the market and you have expertise on the project will be able to do this decomposition. When you do the decomposition, it goes to the lowest level where the team can do the work. That's called activity. And each activity will have set of attributes which will explain all the story about the project, right? And if in software they use a Jira, there is a tool called Jira. In the Jira, they will write the stories explaining all this scenario. If it is not software, they write a documentation explaining what all can be done to the project to get completed. And in that, they will clearly write what to be done first, what to be done second, what to be done third. They write in a sequential way so that the work happens smoothly, right? Saying that, now let me move to next one. As you see now, you saw something called from the work package, you call the activities. Now you have to sequence the activities. If you see here, you're going to sequence it. Why we have to sequence it is, if a project has 15 to 35 activities or 100 activities, we cannot do just like that. We should know the sequence of it. What do you mean by sequence? Sequence is going to talk about predecessor-successor relationship. I'll go back here. Okay, here we had something called predecessor-successor system. If I put here, you have predecessor, you have successor. Now this is going to be done in a practical way. How we are going to do it? We are going to do something called sequence activities. The key benefit of this process is that it defines a logical sequence of work. You understand really well, it's going to talk about logical sequence. I should understand what should be done first, right? So the logical sequence will be obtained here, which will bring the greatest efficiency. By doing in this sequence, how efficient it is, right? That's very important way to do it. So let's understand how we do that. In sequence activities, they take two items, which we did in the previous process, that is activity list and activity attributes. I'll go back and tell you from where we got this. We got this from, in a defined activities, you have something called as activity list and activity attribute. When you decompose it into smaller pieces, you got that. And that's now taken for sequencing. You got that and you're going to sequence it now. You took both and you took some of the details of the baseline, milestones, EEF, OPA. Out of all these two is very important. You took that and you start putting into a network diagram. I'll show a network diagram again and come back. This is what sequencing of activities is all about. That is, once the project starts, activity A should happen, B should happen. When A and B happening, parallelly C and D can happen. If it is a software project, they start doing the design. They start doing the design and development of, this is one module and this could be of other module. It can be. If it is an infrastructure product, they will go for the foundation work, when again they start doing the other metal and steel related or procurement activities work. It could be a parallel process also, right? That will happen. I'll go back. Now we have the list of activities. We use something called precedence diagramming method. It's a very famous method which will help you to say that you put in a sequential way. It's called precedence diagramming method. The image which I showed you with the network, it's called precedence diagramming method. Once you learn that, you will learn two more factors which I'm going to explain you, which is on dependency determination, leads and lags. I'll talk about this. When you do that, it will create a scheduled network diagram. Network diagram is nothing but a relationship of activities one after the other. Now I'm going to talk to you with the network diagram. Then I'm going to talk about two factors. Let me take you further on. If you see here, this is called network diagram. What is network diagram is? It is something, a pictorial representation of a sequence of activities. As a team, as a manager, as a leader, we should be aware what is the sequence of flow while completing the project. When you start the project, it will go with activity A, activity B to complete, then you go for activity C as well. Now point here is, you're much aware that it can happen parallelly. This could be of design, this could be of development, and this part can be of module, 1. This could be of module 2. Here again, it could be of design. This could be of development. And this all go on integrated here. Right. Now, we should know that only after A is done, B can happen. And they call it as finish to start relationship. Only when this is get finished, this can start. That's the relation on that. But there is no dependency for A and C. C can start working parallelly. And D can work only after C gets completed. Now, the message here is there could be some activities which will have dependency with one another. Some don't need the dependency. They'll proceed on their own. Whatever it is, it's come and merge up in a place called integration and it get closed off. So in a project, you will have multiple tracks. Here we have only 2 tracks. There can be one more track also. They will have something called Z coming off. It can be of Y coming off. There will be a lot of modules. There can be one more track here also. Could be. The point is we should know what is the sequence of it, and that's being put in a network diagram format. And this how you do? Again, it is by domain expertise. I'll show a little more. This is called precedence diagramming method. I'm showing the same thing in a different form, little more added up. There can be activities running C, D, and again parallelly G goes off where B, F, and H. Each one is an activity. When you see some number here, it is a duration. The duration of completing that activity. It could be days, it could be hours, or it could be even months. It's a duration of particular activity. If I say activity A, it could be a design. Activity C could be of development, right? If I take a bridge construction, taking 10 foot of ditch, it could be of activity A. And then activity C can be of raising a pillar for the bridge. And activity D can be of laying the road for the bridge. So these are some activities. And this is the point, what you see here is a time taken to complete it. Now the question comes, how do I know it takes 7 weeks to complete? How do I know it takes 10 days to complete? How do I know it takes 12 weeks to complete? Now we are going to do some calculation for that purpose. I will explain you that how we got this 7. For now, understand that there is something called network diagram. There is something called as precedence diagramming method where it helps to put in a sequential way. And after this, we will start working out on the timeline also. I'll show the timeline factors. Before going to timeline, there is one more part I want to explain you on the relationship. I'll go back a little bit. I was showing that only after C gets completed, D can start. Only after D completed, G can start. There is a dependency on that. At the same time, when C is happening, B can also happen, right? So something like there is no dependency in this area. It can be parallel. Now let's see how they define the market for these terms. And this relationship is called with the 4 stages. One is finish to start. Task B can't start until task A has finished. So there is some relationship between both finish to start. There is always a term called as the predecessor and this is a successor, and there is always a dependency between these 2 guys. Only when A completes, B can start. That's finish to start relationship. There are relationships where they use a finish to start relationship. And this is the one 98% of the project activities are done. Most of the time, the activities have a relationship in a way that when one get completed, the next will start. We have a scenario here where start to start. When A started the activity, and simultaneously B can also start. I'll show examples for it. For now, understand that there are certain activities which can happen parallelly. When A started, B can also start. There is one more process called as finish to start. If you see here, B cannot finish until A has finished. Only when this guy finishes, B can also finish, right? Here, if you see, A finishes, until then B can't start. B can't start. Here, B can't finish. That's the difference. If here start to finish, A has to start, then only B can finish. It may be slightly confusing. When we see an example, you'll understand more. I'm going to show one more example here. If you see here, the same is being expanded really well with a real scenario. Here we're talking about finish to start relationship. Hardware needs to be assembled in a computer so that the installing of software can start. This activity should be finished, then only this can start. Let's see paralleling. Writing a document should finish, then only editing the document can finish. Makes sensible. You have to first complete what you're going to write, then only editing can start. Finish to finish. This to finish, then only this can be finished. Now, if you watch out start to start, pouring building foundation, you pour in the foundation cements to start so that level the concrete can start. It's a parallel thing. In software, you have to develop the coding part, simultaneously we have developed that test case part, right? And that's going to be of start to start. There is something called start to finish, where shut down your old accounts, what you have, which will help you to finish new account payable system. You have to start a new accounts for that system. So this is a very unpeculiar case happening, and they're saying that this is very rare scenario. This kind of situation comes up. If not, 98% it happens with this. The rest will be covered by parallel activities. And this is the general relationship followed in any activities. Now I'll tell you where we are coming from. We came from a project, then we had a work package, and after work package we had something called activities, and that activities are now into sequence. We are putting a sequence for it, and that's what you're seeing here. Finish to start, start to finish, it's all happening. But end of day, it's all in this order. You have a project, work package, activities. So far things are good for Eric and Stephen, getting some inputs.
Yep, everything's good.
Fantastic. Thanks for confirming. So I know slightly dry one, this area. Be with me for some time, so you'll get the grip of it. Because this is an area where we understand how the activities talk to each other and what is the timing factor happening. At the same time, it will be slightly dry. I agree on that point. So we'll go deep a little more, and I'm going to help you to understand the dependencies. Whenever there are activities, there are going to be good amount of dependency. And you know, in your project, if you want to do action A, action C should be completed. So on that dependency, we should know, is it a mandatory dependency or a discretionary dependency? In exam, you may get the questions talking about mandatory dependency. However, they use a term called as hard logic. That's called mandatory dependency. The term used in PMI, PMP is hard logic. These are the legally or constructually required or inherent in the nature. It's very mandatory. You can't do anything, in the sense that only when the foundation of the building has been done, you can raise a wall. It's a very mandatory dependency. You can't avoid it. There is a discretionary dependency, the next one, which is also called as soft logic. This discretionary is a kind of a preferred logic. You prefer something like, okay, let me first complete the part A, then we'll go for part B. There is no dependency on mandatory there. It's a discretionary. We decide what need to be done, right? So these dependency are at the discretion of project team and are a preferred dependency based on the best practices of work done in the past or defined by the SME. The subject matter expert says that, guys, why do you do this? Do this way. It's going to set a dependency on our own. Okay, that's discretionary. And we have two more dependencies, which is going to be of external and going to be of internal dependency. External going to be of third party, where you wait for some supplies to come from the third party where you start the work. Internal is going to be within your team. There is some dependency. You wait for a particular resource to join, so you start the work. So these are the dependencies which will have impact on your project. When you say impact, I'll go back. I was talking about something on network diagram, finish to start, start to finish. This can have dependency. Only when the wall get completed, painting can happen. Only painting get completed, wiring, sealing work will happen. After only the wiring happens, switch ports can be done for the wall. If it is an IT, first only the design is done, then you go for database structure. Only database created, you go for tables and information inside that. Only the Amazon cloud server is ready, you will start able to deploy it. There'll be some dependency going here and there. By your expertise in the domain, you will start talking about how this dependency can be managed. That's a dependency determination. Now the third point of the schedule management, I'll come back and show you what I'm trying to say you here. We learned something called precedence diagramming method for sequencing the activities. We were learning on dependency determination. Who will have a dependency? It is a mandatory. Is it a discretionary? We'll learn that. Now we are going to learn something called leads and lags between the activities. Okay, when we do that, it will become a network diagram getting ready. I will show what is leads and lags. Okay, here it is. Leads and lags. This is something very much evident in every project. We will have always a situation where activity should wait for another activity. An activity may not need to wait, it can start on parallelly. Now, how can we explain it? It's called as a leads and lag. Lead means the time duration where one activity waits for another activity. Okay, I will try to show an example. Have you guys seen Olympics where Usain Bolt running?
Olympics or what?
Usain Bolt, the athletic star running on the ground.
Oh, I have not, no. Who said
You know that you know the Usain Bolt who runs the fastest man in the world?
Okay. Oh, okay.
Okay. Okay. Yeah, the fastest man who runs so much fast in a track, right? He wins a gold medal multiple times in Olympics games. I'm just going to talk about athletics here, where I'm just showing 4 boxes here, 4 rounds here. If you see the screen, you will see 4, and I'm depicting here about the relay race in the Olympics. If you know relay race, they'll have 4 people running in that. Right? Have you seen it?
Okay. Yep. Oh, I mean, yeah. Okay. Like the relay race with the baton.
Yeah,
Yep.
you got it. You got it. Okay, I believe you're a sports person there. Okay, great. Okay, so what will happen in the relay race is there'll be a person here. There'll be a person 1, and you have person 2, and there'll be a person 3, and person 4 is Usain Bolt. Bolt. Okay, Usain Bolt will be here waiting for the 4th guy. If you watch the Olympics race, there'll be person 1 starting and run and come to 2, hand over the baton. 2 will pick it up, go to 3, and 3 will pick it up, go to Usain Bolt. Usain Bolt pick it up, go to the finish line. This is the relay race. Now we'll use this to learn the leads and lags. Now the lag is nothing but the time between these 2 activities. When the activity is happening, activity 2 has to wait. The waiting time between these 2 activities is called as lag. I'll put it here. The waiting time is called as lag. It is the activity is waiting for other activity to complete the duration of the work. So in your project, you will have certain activities which has to wait for the other activity to complete. That will be called as lag. In this relay race, activity 2, activity 3 will have some waiting time because they have to get the baton. Until then, they have to wait. That is called lag. Now let's see the lead. Now the running person, 3rd person, is approaching Usain Bolt, running in a good speed with a baton. And when this 3rd person is running towards Usain Bolt, do you think Usain Bolt will wait in the track or start running? Okay, there is a question here to Eric and Stephen. Do you think Usain Bolt, the fourth runner, will wait until 3 approaches him or start running little bit before 3 reaches him?
You can start running beforehand.
Fantastic. That is called as lead. Now, why we call it as lead is we may not need to wait until 3 come very close to Usain Bolt. In a sense, Usain Bolt will be waiting in the track. The moment 3 comes 50 meters distance, Usain Bolt will start and running. Now, what will happen is these two activity will be running a little bit parallelly, and Usain Bolt will get the baton and start running with the full speed. What is the message I'm trying to convey here is in activities happening in a project, there can be one activity waiting for another activity. The waiting time is called as lag. And when one activity coming very close to another activity, the other activity will not wait. It will start running, it start working, and that will be called as lead. In software, when the development is happening, test cases will start writing on. In infrastructure, when the blueprint of the building getting ready, already the procurement of material would have started. They start getting the steel, cements, and paint before even you complete other base work. So it means there can be something lead. You take it on and start doing it. All right. So this is something which we follow in leads and lags between activities. Is that giving little clarity for you on leads and lags for both Eric and Stephen?
All I know is that when I take this test, I hope I can remember all this because I've been doing all this stuff for years and years and years. And as we're going through it, I'm like, okay, yeah, I do all that. I just hope I can remember the lead and the lag and all that jazz. Oh my God.
Fantastic. Good to know that you're getting it. Maybe we will relook at the books. You will easily catch it up. If not, also you're going to have the video of the session. You can replay the video of the session. It will help you to connect again. Yeah. When you go closer to the exam, just play the video and listen to this part, and I'll tell you easily will connect well. All right. Great. Thanks for the confirmation. By the way, where are we on the time? Do you think there'll be a 10 minutes break will help you?
Yeah, 10-minute break works for me.
Yeah, it works for me too.
I know it's a subject that's going very deep. I shouldn't tax you much. So what we'll do is we'll take a 10 minutes break and come back and start again. Right?
This is the plan.
Okay. Enjoy the break.
I'm back. If you're good, let me know.
Yeah, I'm good.
Oh,
Yep, I'm
fantastic.
good.
Fantastic, fantastic. Thanks for confirming. I hope the dinner is going well there. Done.
I had a really mediocre pizza.
Okay.
Yeah.
Okay.
Certainly wasn't as good as last night's dinner.
Okay. Eric, your daughter slept? Little one?
Oh, last night, yeah, but she's not asleep now. She'll probably be
Oh,
going to sleep by the time we finish up.
okay, okay. Yeah. She too be enjoying the PMP, huh?
Yeah, we'll get her in there.
Okay. Fine. I was spending little time on the network diagram. I'll go a little more detailed and explain a little information about the network diagram. I know this is a bit complicated subject in the sense of explaining the network diagram and the scheduling part. And bear with me for subject like network and the tomorrow cost. After which things will get a little easy.
Can't see it, but above the fridge, in the cupboard, on the top left side is a back.
Okay, that's something good.
Sorry about that.
Okay, okay. I was just telling that scheduling and costing will be slightly tougher subjects. After which things should get better. So today and tomorrow going to be a bit heavy for you, and after which things will get normal, where we'll learn most of theoretical stuff. Okay, on network diagram, which I'm talking about earlier on, which has a predecessor, successor, relationship, dependency, right? That's all happening through. Now, in a real project, this is how the network will look like. It even be more bigger. Here it is very smaller part they put over. In real projects, which are massive projects, it will be so high with a lot of relationship. So being a manager, we should be able to tackle it. We will be able to handle things. You may think an activity D can happen after or C can happen after H, but in reality, it may change suddenly. The relationship may change. Then you have to move from one place to another place. So, point is, as a manager, we should have clarity about each activity happening and how the relationships are. Is it a finish to start, FS, or it a start to start? We should have little clarity about there as we keep moving forward. Of course, we'll get it. As you become a manager, you will start tracking more activities. Now, I will take you a journey of estimating the activity duration. And this is a whole core purpose of schedule management. When I say purpose of schedule management, we were doing something called, we had a project and we had activities, and each activity had a bunch of, each packages have a bunch of activities, right? This is how we had. Now, we need to know how much of time it will take to complete this work. Okay, this is hierarchy it happens, and each one is one activity. Now we should know each activity how much time it will take. How to know the time factor, and that comes over here, right? And that's going to come over here in a sense of estimation. If you see this particular slide, it's going to talk about estimate. They're going to start to use a keyword called estimate. When I say estimate, I'm going to estimate per activity how much of time it will take. How to estimate it? There are 4 methodologies used for this estimation, and these methodologies are very famous in the industry and it is used for a long time. It is not now, it's for so many years they're using it. I'll tell you how it works. When I say 4 methodologies, the first methodology starts with analogous estimation. What I do here, I'll try to show you how this analogous estimation comes up. So we have something called analogous estimation. The first one, when I say analogous, it is a historical record. We will take some historical projects which happened earlier on, and that too have the same kind of activity which you do now. We will copy and utilize the same way of estimation or same way of calculation. For example, a bridge construction, a pillar took a month to complete,
in California, and if you're going to construct a bridge in New York, you will consider the same old record and assume it, and this bridge and this pillar can also take 1 month of time to complete. Or in your project, you will have multiple activities happening, and this multiple activities, you will watch out the previous activity which happened, and if it is similar to the current activity, you will take that as a benchmark. So historical information is something you copy from the previous historical records to make an estimation for your activity, which is a current activity. Other one goes on parametric estimation. In parametric estimation, you will do historical plus parameters, right? So what will happen is you use parameters. Historical information is, I was talking about something happened in the previous project or previous phase of this project, and you start utilizing that data. And after taking the data, you will also add your own parameters. I was talking about a bridge construction in California, and they found that it will take a month to complete a particular big pillar. And they will use the same data for a bridge construction in New York. Whereas the soil grip and the weather condition will be different in New York than in California. So what they do is they add those parameters in the historical information to make a calculation. If it took 30 days in California, with the parameters what we have, it can take 45 days. So that's how the calculation happens. So parametric is, again, you copy the historical plus you add the parameters. That's a parametric estimation. We do analogous and parametric estimation when the scope is not fully defined. Scope is not clear, right? So there is not much clarity on the scope. It's a high level scope description is happening. We'll use it, right? This both will use that way.
In the example you're using, actually, it's not exactly correct because there's going to be external things that are going to dictate the time that it takes to build that. Because New York City, if you're building that in New York, you're going to have a lot more issues with the unions to begin with.
Right. Of course.
And you're going to have weather delays.
Of course, you're going to have those can be fall under parameters.
Okay, under parameters. All right.
Okay, so you're going to use the parameters there, and you're going to do that. And yeah, right, Stephen, at that point. Thanks for bringing it up. So how it works out is analogous is purely of historical information where the scope is not clear. They right away tell that we are able to clear the scope, but can you give an estimation of how much time it will take? So they can look out a work which happened sometime back in the history and try to reutilize the same timeline and tell that this could be the timeline. They can't give the estimation clearly. It will be an estimation which is called as ROM estimation. It is called as rough order of magnitude. The rough order of magnitude will fall in a percentage which is fluctuating plus and minus. So it's just scope is not clear. So scope is not fully described. When it goes to parametric, they take historical information and start adding parameters. And that will not be much accurate to the calculation. It will be falling between some percentage. What Stephen said is absolutely right. Definitely there could be union, there could be weather conditions, there could be climatic problem of fundraising, a lot of issues are there. But they don't consider it in analogous because they put it as a fluctuation. There could be plus or minus 75% to 50% change in the estimation what we make, right? And also they say that analogous estimation is not an accurate estimation. The accuracy level will be very less. It is because we are just copying from the previous records. When I go to parametric estimation, there also the estimation may not be accurate. It can be fluctuating because the estimation is not clear now with the input what we got. Now there is third estimation, they use 3-point estimation, and which is also called as PERT, Program Evaluation Review Technique. Here, only when we get a little more clarity about the requirement, what we are going to do, we'll go for 3-point estimation. And this is going to be a bit closer to the estimation. Again, it'll tell you here also there'll be some fluctuation. I'll show you what the fluctuation is. For now, understand 3-point estimation is a little more closer than analogous and parametric estimation, because analogous and parametric were using historical records, whereas in 3-point estimation they start doing on the actual, for which they use a formula. I'm going to show the formula a bit later. For now, understand 3-point estimation is also called as PERT, Program Evaluation Review Technique, which use a methodology called as optimistic plus most likely plus pessimistic divided by 3. They use this formula. They have 3 variety of estimation. They think about optimistic situation, they think about pessimistic situation, they think about most likely situation. So you're touching both the extreme and also the feasible way, and then go for the estimation. What I mean by here is, optimistically a person will say that a work can be completed in 30 days. Pessimistically, a person will say that work can be completed only in 60 days. Most likely person will stand in the center. So they see both the corners and also the better option, and then go for the average and then get the value. This is 3-point estimation. I will show that with the example and with the formula. And the third and fourth one goes on bottom up estimation. And this is the very accurate level of estimation. Again, it will be very closer to the real value, but not the real value. So bottom up estimation is the most accurate. When I say most accurate, it's going to be a bit expensive and time consuming. Why? Because now Stephen brought to the point, if bridge construction going to happen in New York, it's going to eat good amount of time and money, because there could be some union related things, it could be weather condition. Now, how do we know that? As Stephen mentioned, there will be a set of team will work on the ground to really understand how much of time it will make or take to start a bridge work in New York. And there'll be a ground study on that. They literally do a work a little bit there to see how much of real time it's taking on. And they start from the bottommost and come to the top level. They roll from bottom to top. And that is a real work and a real time spent on calculation. When they do that, it is called as bottom-up estimation, and this is accurate, little like close to accurate, right? I won't say accurate, close to accurate calculation. So we have 4 stages of calculation, and these calculations goes like, first one is analogous estimation, which talks about the historical record, in the sense, which talks about historical record, and it has a calculation. It has historical record, and where it talks about the happenings which happened in the previous project, or in your current project you did activity A and activity B. Activity B can look on activity A, how much of time it took over. You look at something similar like this happened in previous record and start utilizing it, right? But the accuracy level will be literally low, because we are just copying it. We're not doing any low level calculation. When you go to parametric, we take the same historical record, but add your own parameters. If in California, it is something like this, in New York, it will be something like this. You will add your own parameters. When you add that parameter, there are chances a little more that it will be clear, but still, as you're copying the historical record, definitely the accuracy can't be great. But why we do that? Even though its accuracy is not good, why we do that? The reason is, there is no clear on scope. They are still working on it. The initial stages of the project, the beginning of the project, you cannot give every estimation perfectly. But at the same time, the sponsors and the top management will expect you to give a estimation. So what we do is, in those scenarios, we go for this kind of situation where you copy the historical record and give an estimation, right? That's on need basis. And the next two estimation talks about little more accurate. When I say little more accurate, 3-point estimation will talk about using the formula where it goes optimistic, pessimistic, most likely. I'll show you a formula page now. For now, understand 3-point means you watch out 3 different estimations, like optimistic way, pessimistic way, and most likely way. And that's 3-point, little more closer to the accuracy. When we go to bottom-up estimation, that's the estimation which we do from the bottommost level, where the real work is being calculated. There'll be a market study happened. There'll be set up team work from the bottommost level to show that it will take really 45 days to complete a pillar in New York for a bridge construction. It will consider the weather condition or climatic conditions. It could be of any social issues. It could be of something on the infrastructure problems, or it could be of material unavailability, traffic congestion in New York. All be considered and really they make a calculation. But if you want to do that, you have to spend money for it. You have to spend time for it. So bottom-up estimation is bit expensive. Estimation is bit expensive, but the accuracy level will be very high, right? By the way, Eric and Stephen, are you getting that this 4 estimation, what it is actually?
Yeah, I think so.
Okay, I'll show some more slides to explain it much more deeper. For now, understand that there are list of activities, and these activities to be estimated either of one or use all of the methodology. While estimating, you're going to get the duration of estimates. So each activity, how much of time it will take, that's going to be calculated. If you want to very clear what I do, I'll go a little back. You saw something here, like 7, 10, 12, 6 in the screen. And it is nothing but the estimation. It could be of parametric estimation. It could be of analogous estimation. It could be of bottom-up estimation. And this activity could be of pillar work in New York bridge construction. It could be of paint works. It could be of making a ditch out of it, making a road connection. So it could be of each can be one activity. And this estimation comes out of any methodology. It could be any, depending on the clarity of the requirement. If the requirement clarity is clear, I will go for bottom-up estimation. I will go for 3-point estimation. If the requirement is not clear, I have to choose a historical information. That is, I'll go with analogous estimation, or I'll go with a parametric estimation, right? It depends purely on the level of clarity we have on the requirement. We choose a methodology. Coming back, we have something called activity list, and also we have something called resource calendar. When you do the estimation of the work, we should also consider the resource availability. Here, when they say resource, it's talking about human resource factor. You should know what is a calendar of available resource who can do this work. That also will impact the estimation. Of course, it will. Only based on the resource availability, you'll be able to tell when the work will get completed. So that reason, we should have a resource calendar. The resource breakdown structure, it will talk about human resource as well material, what all are dependent to complete this particular task. So overall, the goal here is we're going to estimate the activity duration. We took the list of activities and its attributes, which explains in clarity. And we have the resource who is needed for this project, and some of the resource related to material also being added. And then we use this 4 methodology. It is purely decided on the number of clarity of requirement. We go for the methodology, and saying that will help us to create the duration estimates. Now, duration estimates can be for each activity. I was keep saying that a package will have list of activities, right? So each activity will get some duration, and that is going to be calculated, right? And if this is an work package, and this is an activity, right? This is an activity. Each activity will go for some estimation. Let's say now you make an estimation using analogous, saying activity here. You made some estimation. You will say this takes 2 days complete, and this will take 4 days to complete, and this will take 3 days to complete. Let's say activity here, I will take a software here. In a software, you have a work package. That is, the work package talks about a new web page design for Facebook. A web page should have user profile creation, and you'll have some design for the screen, which take 2 days. Some information recording to database can take 4 days, and some retrieval of report can take 3 days. And how they got this 2, 4, 3? When the activity has a clarity of requirement, they'll go for bottom-up estimation. When this activity doesn't have clarity of requirement, little lesser there, they'll go for 3-point estimation and understand some calculation. And when this activity does not have any information, they're just saying that you have to show a report for Facebook. What kind of report? Not clarity. When you want this report, no clarity. And they say that how much of data to be fetched in? Not much clarity. Then they'll say that they go for analogous. Whenever analogous will have a history record, whenever a report should be generated, generally it will take 3 days to complete. So they can use analogous method and say that if it is a report, it may take 3 days. Only when you get the clarity, you can be very specific on the information. You can give some details. If it is again coming back on the bridge construction in New York, it's a package. I will take one package as one particular phase of the project, and they divide into 3 activities. And in this activity, if the requirement is very clear about it, they'll go to the bottommost level, understand the problems, understand the constraints there, and then that will create a particular duration. When I talk about constraints, I believe you remember the constraints which I discussed at the beginning of the day. The constraints can be of scope is a constraint, schedule is a constraint, cost is a constraint, the next resource, risk, and what else we have? We have one more constraint. Can anybody tell it? We have 6 constraints.
Communications.
No, communication is not a constraint.
Oh, wait a minute. Hold on here once. Let's see.
Quality.
One more is, oh, Eric rocked it. Yeah.
Quality. I knew that.
Yeah, 6 constraints, right? As Stephen brought out, hey man, New York is not going to be the same city like California. Definitely these all constraints will come into picture. When you decide on the timeline, you will also decide based on all these constraints. You'll watch out the scope, cost, resource, risk, quality, and then you decide a timeline, right? And to do that, you should know the clarity of the work, what you're going to do. The more the clarity, the better the estimation it is. But unfortunately, customer will not give every requirement clarity for you for every task. Some will have, some may not have. For that, you can't say that I can't do the estimation, but you have to do the estimation. In the area where you don't have a clarity, that will go for analogous and parametric. The more you have the clarity, it goes with 3-point and bottom-up estimation. When you do that, you also to justify why you say it's 2 days, why you say it's 4 days. How you do that? You have to give something called basis of estimates. It's again going to be one of the document where you're going to fill in. I won't say document, it's an information. You're just going to fill in, tell that on what basis it's 2 days, on what basis it's 4 days, right? So that will be written down there. So why we are doing all this information here is to make our team and ourselves very clear on what work we are going to do and what is the overall estimation it's going to have. And also, I have to keep my stakeholders informed. I have to keep my sponsors informed what I mean by the calculation. What is the background behind that? Why I'm saying this information takes 4 days or 6 days or 6 weeks, and that will be written down in the basis of estimates. Okay, so for what we did here is we made an estimation for the activities which we made through decomposition. If you remember really well, we use a tool called Decompose. Okay. What we did, this Decompose is a tool utilized to divide the work into pieces. A work package using Decompose will become an activity. After getting an activity, you start your estimation. The first level of estimation is we did through all these methodologies. Okay. In the 4 methodologies, only 3-point will have a formula. Rest all are just by analysis at the level of information what we have. Right now, what I do, I'll show an calculation screen. Okay, here how to look at the screen is in the initial stage of the project, when the requirement is not much really clear, we go with analogous estimation, where you use a historical record. You go for historical records. And when the planning stage of the project, we have little more information that can become parametric. You will have a historical plus you will have the published rates. When I say published rates, it's a little more informative about your project and your details that will be got together. If you see here, the accuracy level is very low and slowly started going high, right? Now, the third stage is talking about that is on the 3-point estimation. When you're very closer, little more closer with the requirements, we can go for 3-point estimation. That is nothing but PERT estimation. And when you go to closer real deep inside, it will become a bottom-up estimation, not a rolling one. It's going to be bottom-up estimation, which will have much clarity. If you see, the accuracy level goes higher. As and when we get the requirement clearly, the accuracy level keep on going high. So you can't expect in the beginning of the project, everything will be there. So you have to go with analogous. And in the planning stage also, you can't expect more. That can be parametric. As you progress further, it will give the clarity. But when you say progress further, the project will keep rolling on. Nothing will wait for us. So as when we proceed on, we do more estimation. So that's why they call us rolling wave planning. You keep moving further in as and when you get the requirement. There is an explanation given to you. You can read it a little more when we come back to these pages for you. But understand that it is analogous is you pull out the historical information for getting the using historical data from a similar activity, as simple as it is, right? When you go for parametric estimation, which an algorithm is used to calculate cost or duration based on historical data and project parameters. If you read it well, you have to take the historical data and project parameters. You will add those constraints. Like Stephen mentioned, Newark has its own parameters. You have to add those parameters, and you even add the size of the square footage. We talk about square footage in construction, right? You will add more parameters. That's what called parameters. You add more, and that will give some estimation, right? That's about the these two estimations. I will take you to 3-point estimation. In 3-point estimation, they use a formula. The formula goes like this. They'll have optimistic, they have pessimistic, most likely, and pessimistic. 3 estimations. In the sense they go to both extreme. This is one extreme, this is the other extreme, and that's the center guy. They put all this thing, and it is called as triangular distribution. It has a name also called as triangular distribution. If you see here, triangular is used when there is insufficient historical data. If you see one more point, triangular distribution is used when there is insufficient historical data or when using judgmental data. See, when you have historical data, you went with analogous and parametric. Imagine this is the first time you're doing a project. When a NASA launched its first rocket, that could be the first kind of project for them. If I ask the NASA engineers or NASA project managers to come out with the estimation, they don't have any historical record. Whom they look out for? Then they have to go with something on their own, and that's maybe something called triangular distribution, where there is no insufficient historical data. So what they do, they go for optimistic, pessimistic, most likely, and divided by 3. And this is something going to be of judging something based on both the extreme situations, and that's going to be of 3-point estimation. What we are seeing here is called triangular distribution. We have one more calculation which is called as weighted average. What they do in weighted average is they'll give weightage for optimistic plus 4 into most likely.
Oh, good God.
I know I'm going to kill you guys. This is going to be pessimistic divided by 6. Okay, what I'm trying to tell by this formula is there is a situation where they give weightage for most likely. That is, they want to add most likely with the 4 points because there's a high probability of most likely happening. If you see in this formula, it goes on triangular distribution where optimistic, pessimistic, most likely divided by 3 because it is a triangular distribution. Triangle means all the 3 edges are equal. Whereas in weighted average, it's going to be of optimistic, pessimistic, in between the most likely given 4 points extra. Assuming higher weightage, this can happen, this scenario can happen. And then they divided by 6. That's weighted average. So this is another way. In exam, you may find a question where they ask you to calculate 3-point estimation. They'll give a situation, and this situation they'll talk, there is a situation where optimistic 10 days, pessimistic 25 days, most likely can be of 12 days. Now, can you tell me what is the 3-point estimation for this scenario? If a question comes like that, you should use the methodology given here in a triangular distribution. On the same question, they'll tell that there is something more weightage given for a most likely scenario. If they ask you to do the weightage calculation, weighted, you have to use 4 into most likely. So this is how it happens. I will show a screen which has this formula. Okay. I know you may hate the formula, but still, this is what the PERT calculation happens. The PERT calculation I'm showing here, what I'm showing here is, this is on weighted average. Optimistic, pessimistic, 4 into most likely divided by 6. Right? That's called PERT calculation. Program Evaluation and Review Technique, which helps you to calculate the duration of a activity. You're doing that for a reason. Anyway, these formulas may not be used for you, but I'm just put over for purpose of understanding. And this may be useful, which is called for standard deviation. We're going to show the deviation. Imagine you're calculating by this, you get 7 as the number of days to complete the work. Now 7 will have a standard deviation. Deviation can be plus or minus 2 days. And this is standard deviation. What they mean by plus or minus 2 days is, it can be 9 days or it can be 5 days. And that you calculate through standard deviation. So far, am I clear to you?
Sure.
Not much, or you want me to repeat again?
Yeah.
Okay.
I'm just gonna, I figure when I get to this portion of the test, I've got a 25% chance of guessing correctly.
Oh, really? Okay. Yeah. But in exam, it's going to be easy. Don't worry about it. I'm trying to explain you all the corners so you'll be better in exam. If not, in exam, it will be very straightforward. They'll give a situation and ask you to make a calculation as it is. But what I'm trying to do is, I'm trying to show you from the real project perspective how the calculation will be. So what I do is, I'll go back and try to explain it a little more again. You will connect it well. Okay. In analogous, you know that we are using the historical record because we have done a bridge, something like that in California, so I can copy it. In parametric, I know that I can copy it, but I need to add a little more parameters, like Stephen mentioned. I have to consider those factors also. When I come to 3-point estimation, I don't have any historical record at all. This is the first time I'm considering such a massive bridge. So what I have to do, I have to go with an estimation, and that estimation is called as PERT estimation. A PERT estimation is something you consider the optimistic situation, pessimistic situation, and most likely in a center. So in a room, I will have 3 variety of guys. One guy will be always optimistic, saying that yes, it's good. Pessimistic guy will say that no, it won't work. So both the extreme guys are in my room. I'll have one center guy, is most likely. He will say that, oh yeah, possible, it can happen. So now what will happen is, I'm considering all 3 folks in the team. One is very bad, one is literally good, one is says in a center. And I put an estimation for that. And most of the scenario, they're considering PERT works really well. And it's a PERT works, that's the one which gives closest calculation. Again, I'll tell you, there is nothing called accurate. You can give the closest estimation. If a pillar for the bridge construction can take 45 days, and that 45 days by PERT calculation, you found that, and there can be variation. It can be 43 days or it can be 48 days. There can be some standard deviation. Okay, so that's a possible. And when we do that, now PMP is saying that there is a chance you can use a weighted average. I was giving an example to you. Weighted average will talk about, the formula goes with like optimistic plus 4 into most likely plus pessimistic divided by 3. What it means here is, we are going to give more weightage for the center guy. Center guy is a very decent guy. He says that, yeah, chances are there the bridge can complete on time. When that is a scenario, we're giving more weightage. I should use 6 here. So it goes become 6 as an average. Now, this is purely dependent on the ask in the exam question or ask in a real life. In real life, if you feel that the center guy is going to be really good, give more weightage. If not, go just with the triangular distribution. For Eric, we mostly use a PERT calculation in your software estimation. Do you have any idea, seen that how the timeline is estimated in a project? Not seen much.
Well, the timelines, I mean, the timelines I use are rolling, they're rolling 2-week timelines. So I mean, they use a similar estimation process, but I don't think they really use an implementation of this formula per se.
Okay, I got you. Stephen, how it's from your side? How you estimate your project time?
I estimate my projects. I've done it long enough.
Experience.
Just experience. I can look at a job. In fact, my guys just finished a project today, and I had it estimated out at 320 hours.
Okay.
And it took them 325.
Wow.
That's so I mean, I can look at a project, and I've done so many of them, and I've done so many of them, both from the aspect of the project management side and where I've physically been on site and actually done the work, that I can look at it and I can pretty much nail it down to to an actual amount of time to do the job.
Yeah, I can see that you estimated 320 and went to 325. It's
pretty 325. Yep.
Pretty close. My goodness. Okay. We want managers like you, Stephen.
So well, I don't get that close all the time, but I'm usually within plus or minus 10%.
I understand. That's why I got your answer. You said that you're going to guess really well.
Yeah.
Okay. Stephen, I want you, Stephen, because I have managers, when they estimate 300 hours, it comes to 600 hours.
Oh yeah, it can, and I've had those, and I've had those where you estimate it and you've got to build and you look at it and well, this is what it's going to take. Well, then all of a sudden they run into something and it just blows your estimate right out of the water. It just, one of those, it's, one of the risks, it's,
that's right.
The risk is, the unknown factors, and you hit one of those unknowns and
risk factors
blows you out of the water. I've been there, done that.
True. Yeah, that's right. Yeah, see, that is a primary reason these guys are putting over have an estimation of with a standard deviation. So if I show the formula here again, they use the standard deviation to show that how much it can vary. If you see here, this is a standard deviation. They take the pessimistic case, they take the optimistic case and divide it by 6. It will show a deviation between this to that. There is a range within which it can vary. For your case, I will tell it's very close. You estimated 320 hours and it came to 325. The standard deviation is very less. You are very close to the answer, right? But in a real scenario or some of the projects, as we discussed, worst cases, it can vary 20% either side. If I say 100 hours, it can go 80 or it can be 120 hours. It can vary, right? So we should know the deviation. See, it is something like this. When I'm going to talk to my sponsor who is going to give money to me for the project, I should talk all the scenario. I should be able to tell them that, guys, I'm using a PERT methodology. By PERT methodology, I can tell you it'll take 320 hours. At the same time, I'll warn you, I'll give an indication that it can vary. It can become 300 hours or it can become 340 hours. So don't jump on me. I'm just giving you the hint. But if it goes to 520 hours from 320 hours, that's the worst day we have, right? Yeah, it shouldn't happen that way.
Now we got a problem.
Yeah, that's the reason they employ us as a leader, as a manager, to manage it. So we should be prepared a little ahead and start working out if anything going bad. We will talk that when we go to the next levels. But for now, we have to understand that estimations are very important in a project. For that, the team should have the clarity, the manager should have the clarity, what work should be done, when to be done, because when is a factor. As Stephen rightly pointed, weather can be a problem in bridge construction in New York. And as I delay the project 2 more months, the cost will shoot up. So I should know when I have to do which task. That's very important. If I talk about software, availability of software developer is very important. The availability of Amazon cloud server is important. I should know when it is be available, what timeline. I should have much clarity of what I want. Until we don't have a clarity, we don't have a path. Putting to Eric, Eric in IT estimation, as I've seen the projects, we use this methodology of PERT. What we do is we take the list of tasks and put optimistic and also pessimistic calculation, and we share with the client. And the client will always choose the optimistic way.
No, it's choose the optimistic. Yeah, they want it done. They want it done yesterday. Yeah.
I like that. They want it yesterday. That's true. That's true, Stephen. Yeah, that's how it goes. They want it yesterday, and they want the highest standard in the world, high quality. Okay, yeah, that's true. And yeah, this is, there is no specific saying that only you have to use PERT. You can use a combination of analogous, parametric, and PERT. Now, if I take example of Stephen, I can feel that you are so much judgmental, but by your historical record. Your brain has all the historical record, whatever you did in the last few years, and you don't need any document. You just think about it. You close your eyes, you think about it. You can think about a project. You will bring out, okay, this will take 5 days, this will take 6 days, this is 7 days, and you put in the paper, right? But as it is your domain, you're expert on that. But if it is a new domain, Stephen is getting in, it will be slightly tougher. In that scenario, probably you have to go with some of the formulas like this and make a calculation. So that's about the part of PERT. And I didn't talk about bottom up. The bottom up is the one, as I said, there is no formula for that, but bottom up is purely on expertise and the knowledge of the requirement. The more we have the knowledge, we go to the bottommost level and understand how much of time it will take. And that will be rolled up to the topmost level. However, the bottom up is a bit expensive. It is because it will consume time. If I talked about a particular project about the bridge again, there'll be some field study will happen. They go look at the soil test. They'll do the weather condition check. They look at the traffic congestion in that place and start doing the activities at lowest level. And they spend some time really literally to understand how much of time it will take to complete the work. So this is going to be very close to accurate, but at the same time, it's little expensive as you have to spend time for it. The rest other three are only the paperwork, or you pull out the historical information. Bottom up is a little more deep inside to understand the clarity. Right. Yeah, this is what I want to show you, the estimation here. A range of 2 weeks, that is plus or minus 2 days. We always have a standard deviation. This is the standard deviation, which indicates that the activity will take at least 8 days and not more than 12 days. When you say 2 weeks, in a week you'll have 5 days, 10 days. They have a deviation of 2. It can be 8 days completed or 12 days, right? This is how it is. A 50% probability of exceeding 3 weeks, which indicates a high probability, 85% that the activity will take into 3 weeks or less. Ideally, they're giving a deviation, they're giving an instigation that this can fall within this timeline. So as a manager, as a lead of the project, you should be clear enough how the project is estimated and what will be the duration. And again, I'll tell you, the estimation once you make in the beginning of the project don't mean that it will be the same overall project. It can vary. So then and there we keep calculating. It's an ongoing process. It's as you get closer, you'll get a little more details and you start doing estimation again. So it's a continuous process you have to do on the estimation process. Right. Now we have crossed the level. I will again recall you if we missed the map. We were here. What we're doing here is we did the plan schedule management. We define the activities. When I say define, we put into pieces activities. Then we made a sequence of activities. That is, we put in a compartments. After that, we did the estimate activity. Here is where you use a formula. You use analogous, 3-point, all we use in this area. Once all this done, we are going to develop a schedule. When I say develop the schedule, we are going to consolidate how much of time it will take to complete the work. Once you do that, we'll move to the next stage. Is called control schedule. And let me take you to the develop schedule process. Okay, this is the other process which is going to talk about how we are going to develop the schedule. What we do here is we have certain things. We have activity list, we have activity attributes, we have some of the basis on what we made the estimation, and what are the duration. Here is where we have the duration of estimates. That is, it will talk about 5 days, 6 days, 10 days. These all is here. And we also have something on network diagram. If you remember it well, we saw a diagram which has activity A, activity B, activity C, and a dependency. This is all taken into consideration. Having all these inputs, we are going to work out something called critical path method. And we're going to see something on leads and lags, which we already learned about Usain Bolt example, and something on compression techniques. And there is something called agile release planning. I will also explain that part. When you do all this information, it will become a schedule baseline. What we mean by baseline, we saw three things. We're going to have scope baseline, we're going to have schedule baseline, we're going to have a cost baseline. It is called as triple constraints. Whenever you see a word baseline, it means it's an agreed deal between both the team and the key stakeholders. The key stakeholders can be your sponsors or the senior leadership management, to agree that the work will get completed in 12 months of time. So that's an agreed deal you're going to make, right? Now, let's understand how to come to this baseline. Now we have a list of activities. You have a schedule network diagram is all with you. Now you have to put it into a packet. You have to make it as a pack. How to make it? We'll go with understand the critical path method. What do you do? I'll take the next stage to show you that. Okay. There is something called critical path method. Let me read the sentence to make you understand. A critical path is a sequence of activities, A, B, C, D, that represents the longest path through a project, which determines the shortest possible project duration. I'll repeat the sentence. Sequence of activities that represent longest path through the project, which determines the shortest possible project duration. Is it slightly, is it good to understand, as we have both longest and shortest in a sentence? If you're getting literally slightly confused, I'll explain with the picture here. Here, there is a picture which talks about activity A, B, C, and D to be done. Now, this overall is a project. In this overall project, when you say 5, this is a duration. 5 duration, 15 duration, 10 is a duration. When you say duration, number of days or number of weeks. Now, how they calculate is, they will add 5 plus 10 plus 15. If you say 5 plus 10 plus 15, it becomes 30. 30. It may take 30 days to complete this particular path. It could be of design, it could be of laying pillar for the bridge, and the rest of the bridge work get completed. So critical path says 30 days or 30 months to complete. Let's go non-critical path. In non-critical path, you have the layer foundation of the bridge activity. You have to do the painting work. You have to do other steps and other roads work. So in a project, you will have a multiple path. One is on the pillar activity, one is kind of road laying activity. Overall, it is a project. And now here it takes 5 days, here again 5 days, here again 15 days, right? If you calculate, it becomes total 25 days to complete. Now, what I want to show you is a critical path is the longest path. If you see here, A, C, D is the longest path with 30 months, which determines the shortest possible project duration. If I want to say the government when the work will get completed, will I tell them 25 months or 30 months?
I would tell them 31 to give myself a little buffer zone.
Okay. And okay, that sounds well. Yeah, you are right. But at the same time, whenever you gave this 10 days, you gave it the buffer. Whenever you gave 5 months here, you gave it the buffer, right? So a critical path is a path. When I talk to my government officials, I'll tell them that 30th month end, I will hand over the bridge to you. So that is the longest path in the project, and that is the shortest possible project duration, right? So when I do the pillar work, simultaneously I will do the painting and road laying work also. That falls under 25 months, and this falls under 30 months. So to the government, finishing day could be of 30, right? Yeah, Stephen said is right. You have to have buffer, and those buffer will be inside this 5, 10, 5, 15. Each activity has its own buffer. But end of day, when I communicate to the government, I should communicate that on 30th month, last day, you will get the bridge, which is functional, right? Now, that's a sentence I'm trying to explain you for critical path. In a project, you will have more than one critical path. There can be one more path here, which talks something more different, saying that get approval from the government, environmental factors, that can also be 30 days, 30 months, right? More the critical path in the project is dangerous. The project is at risk. Why? I'll explain it as. Now this is critical path and this is a non-critical path. End of day, it's overall is a project. Now, when I communicate to the upper leadership team or government, I'll tell them that 30th month I'll complete the work. And the management asks you, oh, is it a critical path? Then you have to say that, yes, this is a critical path and we calculated it and we found that 30th month you can complete the work. Now the question comes is, what is the difference between critical path and non-critical path? The main difference is any activity in happening in the critical path cannot have a slack, cannot have a float. Now, what is slack? What is float? These activities which is falling on critical path cannot take any leave, cannot even waste one day. Every day is counted. And that is the reason we have 0 here, which talks about slack will be 0, float will be 0, float will be 0. What's the point is, float means the time of delay an activity can enjoy. And this resources working in this activity is always a critical resource. It can be human or it can be material. You can see in some offices, some corporates, some resource will be always busy in the project. The reason being is they may be in the critical path activity. They can't even take a 1 day sick leave. They can't even say that I'm not feeling well, I won't come, I can't work. They have to work. No other go. Because if that guy doesn't work on that day, instead of 10 days, it will become 11 days. If it becomes 11 days here, what will be here? It will become 31.
It's going to be, it's going to be 12 or 13. You're going to.
Yeah, it will increase it. But my government official come and ask me, guys, you said me going to give you on 30th. Now it's 31. So you have to pay me the fine. You have to pay the penalty, right? It will happen. So we have to be very cautious. Whenever we take a critical path activity, we put the best resource in this critical path activity. It can be human resource or it can be material, because we have 0 as a float, 0 as a float. There is no room for enjoyment. You have to do this work because a customer is waiting for you to receive the product on the 30th day or 30th month, whatever it is. On the time what we given to them, then exactly that evening, the customer will stand in front of your door asking, hey, where is it? Right? So I should be very cautious on each activity planning. Right. Now saying that, now what is non-critical path? A non-critical path which can enjoy 5 days of buffer. Why 5 days of buffer means we got a message that the 30th day I have to deliver it. If that's the case, when I calculate here 5, 5, 15. It came to 25 days to complete this path. It could be of a painting work. It could be of laying road work, 25 days. So when it's 25 days, I can complete 25th day and 5 days I can relax. I can go to Hawaii and come back, right? So it is something like this. It is a 30 days a critical path and 25 days is for a non-critical path. So I'll get a 5 days. If you see the difference, 30 minus 25, you'll get 5 days of slack, 5 days of float, right? If there is one more activity here, one more is here, and that's having little more activities, right? And if in case that's falling in 10 days, we'll complete it. The slack will become here as 20. 20 will become slack because 30 minus 10 will become 20. Okay, in boxes, it may look peculiar. In a reality, it's something like this. Critical path is the path which you convey to the customer stakeholder. I'm going to deliver it. At the same time, in the same project, you have other path also. The resources working in other path will have little slack, little float to enjoy because they don't fall under critical path. Now, if a resource completes a work on 25th day and they are free for 5 days, what I will do is I'll pull those resources into these activities. I can use them here. I can use them here, right? So what it means is the activity can be swapped in both environment. Any project will always have a critical path, will always have a non-critical path. Whenever you give estimation to the customer, you will give estimation based on the critical path, right? And the non-critical path will happen parallelly. But however it is, its delay will not impact anybody because we know we have 30th day has been decided as a last day. So far things are good on critical path. Eric and Stephen, any question on the critical path?
Not for me, no.
Okay.
It seems to make sense.
Okay. Well, thanks for confirming. Right. We'll move on. I know I'm going to trouble you for a while. I'm trying to explain you more on how the network diagram works. There is something here. I'm not going to go very detailed on it, but I'm going to explain you what it is at the high level, which will help you. This you may not find in PMBOK book. You will find this in Head First PMP book, which I shared with you. What they're doing here is every activity, I put an activity here. This is activity, and this is expected duration. It takes 12 days to complete it. Now, every activity has something called early start, early finish, late start, late finish. What it means here is an activity can have some buffer to start little later or to finish little later. Why we have to do this is when we're in a network diagram, there is a good chance that we can't expect everything starts on the first day. The work can start on the second day or the third day. Even if you start the work 1 day later, can I finish it on time? Even if I start 1 day late, can I complete the project on the day what I given to the customer? So we have to understand how much you can play within that part. And this is called early start, early finish, late start and late finish. For your better understanding, I have put the formula here for the calculation. I just explained one scenario. Later on, we can do the calculation on our own. Early start. The early start is always the first day. Your work will start on the first day. I'm just showing here an activity A. It will take 10 days to complete. Even if it's 10 days, I'm going to start the work on the first day. That is early start. What is the early finish of it? They use a formula here. Early start plus duration minus 1. Early start plus duration minus 1. At 10th day, this work will be completed. Let's say setting the foundation for the bridge work, 10th day gets completed. Next is putting the pillar. So the B will start 10 plus 1. That is the next day. 11th day, the work of pillar should start. That is early start of next activity will be early finish of predecessor plus 1. Early finish of predecessor plus 1. So far you both are with me?
I think so. Well, yeah, I see where it's going so far. I'm getting a little overwhelmed with these formulas.
I know. I know I'm troubling you a lot, but yeah, just take a look of it so that when you read the book, it'll be easy to understand, right? I'm just helping you to what it is. Later, when you read the book, it'll be more clear. Now, each activity has a dependency. We put a sequence diagram. After A is done, B should go. B done, C should go. But at the same time, each activity has some duration, 10 days, 12 days, or 9 days. But now question here coming up is how much I can play with this 10 days. Can I start late but complete early? So for that reason, we have early start comes here, and early finish comes here. Late start comes here, and late finish come here. For which has some simple math to do the calculation. So it starts with the first day and goes plus duration minus 1. The same way for late start, late finish, we have some calculation at the bottom, which will be done in the reverse way. Just a minute. Okay, I'll show the real case here. It will be easy to understand. This is there in a book of Headfirst PMP, which I shared with you. You can look at later point. If you see here, there is an activity A. Its duration is 6. What they do here is they make a calculation. The work starts on the first day. When they start the work on the first day, when they can finish it, early start plus duration minus 1. You take early start plus duration minus 1. 6 plus 1 minus 1 will become 6 again. That is, on the 6th day, the work should be completed. If work completed on the 6th day, the next work can start on 7th day, 6 plus 1. So you have early start plus duration minus 1. That's for this calculation. Now, early start of successor. This is a successor. This is a successor. Early finish of predecessor activity plus 1 will make it 7. It's very logical. When you do 11th day, 12th day, next activity should start, right? If I do complete a work on a Thursday, Friday should be the next work should start. The same logic is being explained in a number form here, so don't get panic. Just understand that when a work gets completed, the next work will start on next day. That's being explained. There is something called late finish and late start, which will come in the reverse order, which I'm not going to trouble you now. For now, I'll expect you to understand there is something called network diagram and something called early start, early finish, late start, late finish. I have the formulas written down here. For now, understand an activity can have 4 corners, and it will help the team to understand what is the best time to start, what is the best time to close the project activity. If you understand up to this, it's fine. When you read the book further on, you will get more clarity where then you relook at this, then you can start the calculation. Not now, because if you do now, you lose much of the information what you learned. For now, just understand there is something called early start, early finish, and late start, late finish. And that is used to find something called float and slack. The float and slack is nothing but I explained little early. I explained here. This is called float. The activity which is in critical path will have 0 as float. Any resource here cannot take leave or unavailability. Work should happen smoothly. Whereas a non-critical path, then resource can take slack. That is 5 days of slack, because the finishing time is only 30th day. Here finishing time is 25 days. So I have 2 difference like 5 days, and I can enjoy 5 days of slack. And this is what calculated in the formula given here. Now, Eric and Stephen can ask me the question, am I going to do this every day in my life? The question is directly no. But it is being done by the software which you are using. It can be Excel sheet calculation. It can be MS project calculation. It can be a Jira calculation. And this is all happening behind the screen. You may not see live in front of you, but it is happening behind the screen. But as a manager, you should be aware of what is float, what is slack. Yeah, if you are that, that's good enough. Right. And this is used total float. To calculate the float, they have a formula. Formula is very simple. To calculate late start minus early start or late finish minus early finish. Don't get troubled now. Just understand this is there in the calculation. I have given the book to you. In the book, you will really have the very basic examples explained. When you read into it, you'll start understanding how they're calculating it. Ideally, start adding furthermore to understand the early start, early finish. When you come on the backward mode, you start deducting it.
7.
Right.
5. Okay, I get it. All right, that kind of, I can figure that out.
Oh,
If I get a test question on that, I can figure that out.
You're real fast on that.
Yeah, that one I can figure out.
Okay, it is called, if you go the right direction, it's called forward past. That is for early start, early finish. When you want to calculate the late start, late finish, you have to start from the back. 18th day is the last day the work is getting completed. Now, what they do is they copy 18 and put it here. That will be the late finish. And when they want to calculate late start, they use late finish minus duration plus 1. I'll repeat again. Late finish is 18th day. 18th day minus 7 plus 1 will give them 12 days time. That is, late start could be 12 days. For now, just understand this. Let me not trouble you more. Only thing I want you to see is when you deduct 18 minus 18, it becomes 0. 12 minus 12 becomes 0. That's where we get a critical path. A critical path will have always 0 as a duration. I mean the 0 as a slack. I'll come back. Here the slack is 0, 0, 0 because they are in the critical path. If you see here 5 minus 5, 0. 1 minus 1, 0. 15 minus 15, 0. 6 minus 6, 0. 30 minus 30, 0. 16 minus 16, 0. Whereas if you see here 15 minus 10 or 10 minus 15, it will become 5. 6 minus 11, it will become 5 because they are the non-critical path. In the non-critical path, if you minus these guys, you will get the 5. Whereas in critical path is all be 0. Right? In order to understand this only, we are making the calculation of early start and early finish. I'll go back. I'll show an example here. I said 12, 12, 0, 11, 11, 0, 7, 7, 0, 6, 6, 0, 1, 1, 0. If I see here, 2 minus 11 or 11 minus 2, it will become 9 as a slack. 10 minus 1, 9 as a slack. Okay, let me help you here. Can you help me to understand what is a critical path in this project? We have two paths, path A, path B. Can Stephen and Eric help me? What is a critical path here?
Critical path would be your path across the top, the 1, 6, 7, 11, 12, 18.
Yeah, perfect, Stephen. You rocked it. So let me see. This is one path. The other path goes, I will start with start. After start, this is the path. After start, we have D.
DC.
Right. And when you calculate this, it says A is 6, B is 5, and C is 7. So it comes to 11 plus 7. It will become 18 here. 18 is 18 days, 18 weeks, 18 months. That's the path. Let's understand D and C. 2 plus 7, it becomes 9. Now tell me which is the longest path in the project. Of course, this is the longest path. And that is the shortest duration my customer can receive the project. Let me put a very poor customer here. Okay, this customer. And this customer may not worry about 9. The customer worried about 18. 18th day evening, the customer will come to my office asking, hey guys, are you ready? If that is the case, and this is a critical path. Anybody working on this activity A, activity B, activity C cannot take any leave, cannot go on vacation. cannot say that I'm not be available. The person has to complete the task. And these activities are very crucial. We have to keep an eye on that, because even one day slipping here, it will become 19th day. And this guy will hit me very hard, saying that, hey, you know what? You asked me to come on 18th evening. I'm there. Where is it? You can't tell them that, you know what? In my team, one guy went off for 2 days, so I can't complete the work. It is not a good answer. So we have to complete it. Whereas if I see here, the activity D can enjoy some benefit. C can't enjoy, because when I say here, it becomes slack 0, slack 0, slack 0. The same 0 applies here also, because C is interacting with both the guys. If you see here, C is interacting with both the guys. It's an integration. It's integration happening here. So C can't say that I can take off anything. No, C is 0. Only people who can enjoy benefit is D. Now, what is the benefit? How much of timeline they can enjoy? It is something like, you have to see this calculation. There is a difference between 18 and 9. The difference is going to be 9 days. So activities running in the second path can enjoy 9 days of float. They call it as float. You can float around. In the sense, activity D can start 9 days delayed, or complete and wait for 9 days. Either way, it's up to us. They'll give you slack of 9 days. They'll give a float of 9 days. Float 9 days given to the activity D. It's up to the activity to decide, I can start the painting work after 9 days, or I'll complete the painting work and wait for 9 days. It's up to us. But you can enjoy. Nobody's going to push you. There's a good amount of time. Whereas the people working here will have float as 0, 0, 0. No other go. You have to work it out. All right. Does it make sense with the explanation?
I think it will eventually.
Yeah, I was gonna say it makes sense, but I'm gonna have to probably go back over this portion of the video a few times.
Yeah.
Okay, I know it is slightly tougher area. I agree. That's why I'm going a little slow here to make you understand. By the way, we are going to be in communication for a while. No issues. I can explain you later again also if you have doubts when you open the book. Right. By the way, Stephen and Eric, are you using WhatsApp application by any chance?
WhatsApp. That's the application I was trying to think of the other day.
Okay. Okay.
That's like the oh god. That's like a messaging. It's a messaging app, isn't it?
Exactly.
Yeah.
Yes. WhatsApp. That was the one Eric was talking about. One that he used with his team members, and WhatsApp is the one I was trying to figure out. We used that with Nokia when we did a lot of work with Nokia and Ericsson.
Okay. Now, why I ask this question is probably we can create a group in that, you, me, and Stephen. So I can clarify then and there questions when you read the books. When you start reading the books, a lot of questions will come. So probably we can get clarified so that you can move forward easily. So maybe end of this session, I'll get the details. We'll start working out and create a group. So Eric, you're already using it? You're using WhatsApp already?
Yeah, I use it a lot.
Oh, okay, then we'll ask Stephen to install it. You can give a hint to Stephen how to do that. Okay, I've just gave you a hint about the network diagram and sequencing part. I know I killed nearly 1 hour with you for that purpose. Don't worry, I will explain you more on that as you get closer. For now, you both got an idea that there is something called network diagram. There is something called as activities. There is something called as duration, floats, early start, early finish. You all understood this. Now you understood. You're going to relook at the video again. Even if you don't get the clarity, you're going to WhatsApp me. I'm going to help you with the details on that. So this is how it's going to be. So no worries on that area. Now there is something called schedule compression technique. I have to talk about that also. When the work is happened as per the plan or planned to go in a sequence way, if you see here, there is something called fast tracking and crashing. two methodology are highly utilized in the market on any methodology, any technology or any domain. What you mean by fast tracking is when you plan certain activity should happen in a linear way. When in a linear way, one after the other. But you feel that you may get delayed to deliver the project, then what you do is you fast track it. What you mean by fast tracking? You will make it parallel. Instead of doing it in a linear way, we put it in a parallel way. It is easy to say, but hard to do. Why? There are high risk when you make an activity linear to the parallel. There can be some errors popping up. There can be some quality issues coming up. But however it is, as a manager, as a leader, you are expected to think ahead, saying that, guys, we can't go by linear. We have to go with the parallel. So you have to look at the consequences, but you have to make a plan. And this is one of the technique used in project management to speed up the work. Of course, we do it, right? Sometimes you parallel it. You speak with someone on the phone and you keep driving the car. Or you do something writing at the same time listening something on the audio. So you do parallel. If you know that it can't be done in linear, you parallel it out. If it is individual to you, it's somehow possible. But when a team is working, you have to be very clear. When you want to say something to be done in parallel way, we should explain really well to the team. If not, team will have a tough time. So fast tracking is one of the methodology. There is another methodology to complete the work faster. That is by compressing. The other methodology called as crashing. Here, crashing means they add more resource to complete the work, right? That is like you know that the work can be done with the 5 resources, and now your sponsor is asking that can you complete a little faster so that I want to see the results immediately, or you may be running late in the project where you have to push it faster. What do? You increase the resource. If you see here, increase the resource. It could be material as well as human resource, right? Now there is also a risk here. The cost factor goes high, and also just by adding resource, sometimes work will not get completed. A new resource coming inside can bring in some quality issues. The resource is not trained really well, it's not that much qualified for the work, but just adding them can bring more risk to the project also. And as a manager, we are liable to consider those points also. However it is, we have to make a call. Do we need a crashing or a fast tracking? And these are two famous methodology used for schedule compression. I'll show one more screen. Okay, if you see a screen here, I'm showing fast tracking and crashing. In fast tracking, the risk is very high. It is because instead of doing in a linear way, I'm doing in a parallel way. When you do in a parallel way, there are a good chance of failure can happen because the work started happening much faster than what we thought. So that's going to be a bit tougher, right? So only when the pillar work is done, the bridge beam should be set over it. If you do it parallelly, there is a chance the pillar could slip down. So we have to be cautious enough on doing on fast tracking, right? We have to be very careful on what we do. Which to be fast track, which shouldn't be fast track, we should be clear enough. When I talk about crashing, we add more resource. When you add more resource, the cost will go high, and also the new resource came in can bring more risk to the project without lack of understanding. However it is, as a manager, you are expected, as a leader, you are expected to do both. Even though there is a high risk on that, even the cost goes high, you are expected to play along with this. We do it in a real life, we do it. The same should happen in a project also. That's one expectation. Okay, here I'm showing an example. I want you, Eric and Stephen, to read through this and try to find, is it better to crash? Which one do better to crash? We have 4 activities, A, B, C, D. And the original duration of activity A is 10 days, 14 days, 5 days, and 9 days. Now there is a ask for you to crash it. When you crash it, it will have some cost towards it. Can you help me to find which activity is the best one to crash? Stephen, Eric, just read the question.
Oh, let's see. Which activity to crash increase the project time by 1 day? I'm not sure.
Mm-hmm. Okay, I will explain one scenario here. You will understand more.
I'm not sure how I would do that.
Mm-hmm. I'll help you. There is an activity called C. It could be of a painting or bridge work or database creation, and it could be any activity. And this this activity originally planned to complete in 5 days. Now I'm trying to crash it. When I say crash it, I want to reduce it to 4 days, right? By reducing by 4 days, I'm going to save 1 day. Okay. The original cost for 5 days is $15,000. The original cost to complete the work in 5 days is $15,000. If I'm going to crash it, if I want to make it down to 4 days, it will become $17,000. Why $17,000? If you understand well, crashing means adding more resource. Instead of 2 people working in the project, I'll make 4 people work in the project. I have to pay extra salary for them, extra check for them. So now from 15,000, it will become $17,000. Now extra cost which I'm going to spend is $2,000. So the crash cost per day is $2,000. Now, if you understand this line which I explained, originally
Okay.
thought but you thought 5 days. Now it will be thinking of 4 days. Now the question is asking which activity would you crash to reduce the project cost by 1 day, project time by 1 day. You have 4 activities. Can you help me to understand which activity is beneficial for the company if they crash it?
I guess it would be C.
Mm-hmm. Okay. When you say C, you're going to incur $2,000 per day, but you will save only 1 day.
But that's all we want to do is reduce the project by 1 day.
Okay. Which activity would you crash to reduce the project time by 1 day? Fine, I agree. But at the same time, do you see anything more beneficial in other activities? Instead of doing C, if I do other activity, can I gain some more benefit? The cost also should be lesser. At the same time also should be higher.
I guess A is going to be your most cost effective because your crash cost per day is lowest. But
perfectly, you nailed it. That's what I expected here, right? Even though C looks good, but to my upper management, I had to tell them that, guys, you know what? You just spend $1,000. I will give you back 2 days, right? So
okay.
it means per day only $500. You spend $500, I'll give you 1 day. Whereas here per day you have to spend how much?
Okay.
$2,000 you have to spend. So if that is the case, A could be more beneficial than C.
If you're doing a 10-day project for $10,000, you're not making money anyway. You're losing your ass at that point.
Yeah. Okay, it's for the example purpose to just give a view. Eric, you are with us. You are able to get the idea.
The general idea, yeah.
Okay.
I was under the same impression that Stephen was originally. I was going with answer C.
Okay. I know certain things will fly over the head. Don't bother. Just relook the video again. You may get the clarity again in the part. But understanding here, what I'm trying to explain is crash means adding more resource. Could be material or human resource. Your senior management is asking you, guys, I'll give you some dollars to you, but show me some benefit. So what you do is you tell that, okay, give me $1,000. I will save 2 days. Instead of completing the work in 10 days, I will complete in 8 days and make you happy. But for that, you have to give me $1,000 extra, where I have to pay check or I have to buy some material, right? So that's a beneficial one. If I choose B, instead of 14 days, I will complete the work in 10 days. I will save 4 days, but I'm going to spend $2,500. It's bigger, huge money. So that's a point we are trying to show you here. Let me take you to the part. Okay, in schedule compression, we have fast track, which you understood that, where you're going to parallel the activity, and we're going to have crashing, which you're going to add more cost by increasing the more resources. And other ways of reducing the schedule can be of reduce the scope. Certain time, the time is shooting high, we reduce the scope. We say that, guys, this can't be done. So that's a reduced scope. Cut quality is also part of schedule compression, but I personally don't like cut quality. We shouldn't cut the quality. Quality is always should be highest priority. Customer satisfaction happens only by quality.
Mm-hmm.
Right? I personally don't believe it, but the system says that if there is a schedule compression as far, you can reduce the quality factors, but it will increase the risk. If you reduce the quality, you will have face a risk. I don't really like this part. And the last one goes on resource reallocation. Yes, this can be done. Does not add cost or increase risk. You can reallocate the resources in the name of compression technique. So this is all to complete the work faster, right? And I come to the last one for the schedule determination. What we're doing here is there's something called agile release planning. It is not part of your exam, but you can understand it. I believe Eric will be very familiar with this. Here, agile release plan, they go by releases. Release 1, release 2, release 3. What it means is in a release, it will be a 3 months of timeline. A release can be of with the multiple iterations. They say iteration 1, 2, 3, 4, 5. It goes on. I will just give a highlight what a iteration mean. A iteration can be of 2 weeks to 4 weeks timeline. One iteration. What do you mean by iteration? You will deliver something at the end of second week. You will deliver something at the end of fourth week. That is going to be a iteration, right? 4 weeks timeline. Okay. So what will happen is a iteration can be of 2 weeks or 4 weeks timeline. And imagine you have how many iterations we have here? Let's say 4 iterations. So 2 into 4, that's going to be 8 weeks, which is going to be 2 months timeline. So if I take this cycle 2 weeks, 2 weeks, 2 weeks, I'm going to keep on adding. That's going to be of 2 months of timeline. So one release is equal to 2 months of timeline. So what they're trying to show here is this could be 2 months of timeline. At the end of second month, you will give something usable to the customer. This again we do in every methodology. Here in Agile, they use a word, something called release. They use a word called iteration. They use a word called user story. Only the naming convention got changed. If not, the concepts are very old concepts, right? But one good thing in Agile is they give it in a very quicker results, rather making the customer to wait for example, in an older project, if it's a 2 months, 2, 2, 2, it will become 6 months. The customer has to wait till the end of 6th month to see something usable. In Agile, every 2 months they give something. If I put an example, if you open your Facebook, every 2 months you will see some new feature coming up. Facebook keep on adding some new features like a photo upload, video upload, photo tagging. They keep on adding some new feature. Do you see the same Facebook which you saw 1 year back or something different now?
Something different.
Different. So they can't say that, Stephen, I'll give a new release after 1 year. Please wait for me. No, they don't say that. Every other 2 weeks, they keep on giving something to you. Whenever you open your internet connectivity in your mobile, it will tell that Facebook has a new version. You want to upgrade. You'll say, yes, it will upgrade. After another week, you'll open it. Again, it will get upgrade. Again, upgrade. Again, upgrade. It keep on going. It means that's a beautiful music. Okay.
My damn phone again.
Okay, every 2 weeks they keep on giving some upgrades, and this is the software related model, and this may not work for bridge construction. Bridge construction will take good quantum of time to show something usable, something going to be of delivered, right? So this is agile release is primarily utilized in IT industry as the expectation is higher, also as it can be delivered quickly, something usable.
I will be using some part of the Facebook when the other part is getting ready. So that's where the agile being explained here. If I want to put very clear, here we have the list of features need to be delivered. That will happen in a two weeks timeline. Collectively, it will be of 2 months of timeline. Every 2 week will give something usable, and release will be something a major part which is promotable to the production. End of day, you should understand that customer is being served consistently in an iterative and incremental way. So that's what agile things happen. By the way, this is not part of your exam, but you can understand what is agile all about. I believe, Eric, you are doing this part, isn't it?
Yeah, I'm doing pretty much everything in this
you are in this
right
iteration.
here.
What is your current iteration now? You are in 1, 2, 3. Where are you now?
Well, we haven't changed version numbers in a while, so
You'll be in some iteration number, right? They'll say sprint number, sprint 2, sprint 3, sprint 4.
yeah, but they don't iterate that way. They iterate based off of the version number. So
Okay.
so like right now it's in version 4.34, and the next sprint will be 4.35, and then the next sprint will be 4.36.
Okay. Sounds good. Okay.
So in this it would be whenever we move to version 5.0, that would be considered, the next release.
Okay, got you. Yeah, this is how it works. Thanks, Eric, for confirming that part. Yeah, this is how the IT industry works through. However, it is other industries may not directly adapt this methodology, but some parts here and there can be taken on. If not, we'll proceed with the same methodology. Okay, so it's a good journey of learning the scheduling part in the sense of understanding the activities and sequencing them and putting into the plan. Now, what you have did so far is you understood how to calculate the schedule and how much of time it will get to complete. We saw critical path. We understood that it will take 30 days to complete or 30 months to complete the bridge construction, right? That's put over. Now, imagine that is done and the team started working on. When the team started working on, probably I have to come back here to help you understand. We did develop schedule, understand how much of time to take to complete the work, right? This is what we did so far. And now already we did a scoping yesterday. Now you know the requirement of the project. We know how much of time it will take to complete the project. Now I can ask my team to work. The team started working. When the team started working, it will start giving some outputs. What it may be output is how much of work has completed, how we are progressing. We made a plan of requirement. We made a plan of time. Now we have to see how the team is doing it. How to see that? There is something called control schedule. Control schedule means it's a policing factor. What you mean by policing factor is you compare against what you planned. You planned something here, you want to compare it to see, are we doing as per the plan? The plan says that within 4 days, the painting work should be completed. Within 7 days, the road work should be completed. It is plan, but are we following the plan? How do we know that are we following the plan? Only when this working team gives some data. Working team will give some data telling that, you know what, today I did this much of work. Tomorrow I plan to do this much of work. They'll give some information. And that information is very crucial to understand, are we moving in the right direction? It is something like this. You took a car to drive from, say, one city to other city. You already planned, I should reach this spot in this particular time. But you keep looking at your watch, you keep looking at your speedometer, you keep looking at the distance where you want to go, and you keep adjusting yourself. In a sense, if your destination is far away and you are lagging behind, what do? You accelerate your car. You raise your speed from 80 miles to 110 miles per hour, right? That's how it goes. Of course, a cop shouldn't chase you. Now you have to rise that speed means you should understand where you are. For understanding purpose, we have something called control schedule. We're going to see this part now. Understand how this happens so that you keep things in control. What I do, I'll take again back to the slides. Yeah, here it is. Sorry. Here it is. We have something called control schedule where we take inputs like you take the schedule baseline, which you framed just few minutes back. You take a scope baseline, which you did yesterday. Whenever I say baseline, it is an agreed deal between you and the key stakeholders, right? And also you watch out the performance of the team, how the team is performing as a collectively. And now I said, I need to see the data of the team. The data of the team comes from work performance data. Whenever I say work performance data, it is an actuals of a team. Okay, work completed, right? That will be in the work performance data. Now, actuals work completed here will be in the work performance data. The information will be here. I will take this information and I will do variance analysis. I will watch out. I will do the variance here against the plan. The plan will be inside the schedule baseline. I'll open this sheet. It will have the plan, how many days it should take to complete the painting part. Now the work performance data comes from the team. The team comes, how much is they completed? I have a plan with me. Now I'll compare both. The comparison will happen variance analysis. It will also see the critical path. Are we going as per the path? We see what is the leads, what is the lags. We also have a schedule compression. Can you repeat me what we learned in schedule compression? We have two compression techniques. Can Stephen and Eric help me? Two compression techniques.
Two, what was them? Sorry, two?
Two schedule compression techniques we learned a few minutes back. What was that?
One is going to be crashing it.
Wow, you rocked it. One more.
And the other one is going to be, well, we don't like it. You can cut quality.
Loading.
No, you guys are very closer. Something starts with AF, but no wrong words.
Well, I know one thing we could do with it starts with an F.
Okay, crashing, you got it. Crashing is adding more resources. I said one more thing.
Fast track. There we go. Fast track.
Oh,
there we go.
Man.
Fast track.
Oh man, you deserve one more Domino. You want a pizza? Okay, that's cool. You guys are so good on that. Yeah, I appreciate it. And schedule compression. So we're going to watch out after comparing the plan and after comparing what the team has done. We're going to watch out. Are we in the path, right? If not, I'm going to ask the team to take some action. That action will fall under change request. We thought to do like this way, and what team is doing here, and we do analysis on that. We do all the review on that. We do the iteration burn down chart. We watch out what's happening, and then we recommend for change requests. And also we give something called schedule forecast. If you are being employed as a manager, if you have been called as a leader in a company, it means you should be able to forecast. There are leaders I've seen in my organization, at least, they are being called as leaders only when they are good at forecasting. If they can't forecast it, they may not be in that position. See, if a manager talks what is currently happening, that is good, but that is not extraordinary. That anybody can tell. Anybody can tell looking at the data what is currently happening. A leader or a manager is highly appreciated only when we forecast things. What I mean by forecasting is when you drive the car and you want to reach a particular city and you know you're running late, but still you will be able to forecast at what time you'll reach the spot, at what time you will be getting to this particular place. And if you can forecast exactly and get closer to that, that's leadership starts. One of the example I'll tell you, Stephen said that he was able to forecast 320 hours as a completion. That was very closer to the completion line. And that's the best way a leadership can do, right? So the more you are closer to the answer, the more you are able to say what could happen, and the management team and leadership team start liking you, right? And to do that effectively, you should have a look on what was planned, what is currently happening, and you have to see the variance accordingly. Thankfully for Stephen, it happened in 325 hours. It was very closer. Even if it is not going to come closer, Stephen would have seen the page again and again every other day to check, make sure it is falling within 320 hours. If it is going to go beyond 320 hours, Stephen will raise an alarm to the team. Guys, you guys are shooting high. Be careful. Watch out. Watch out. Watch out. You keep on alarming it and making sure things fall in track. And that is expected from the manager. That is expected from the leader, right? So just putting a plan is not the end of the story. After the plan, you have to keep a watch consistently. Are we on the track? If not on the track, bring them back to the track. So that's a very crucial role for a manager, right? Saying that, I'll take the next chart. When you go for agile way, there is something called burn down chart. I believe Eric would have seen it. I'll just give a highlight for both of you to understand. Burn down chart is something will show the remaining work to be completed. If you see here, the chart tracks the remaining work to be completed. Okay. And what they do here is there's a number of weeks or number of months, say 1 to 12. Guys, get down. So 1 to 12 could be the number of weeks or number of month, where we have the number of, they call it as points, story points. I want to complete 50 items, 100 items, 150 items, 300 items. So here it starts from here. If you see the straight line, this is a line, is a planned value. Planned is by the month of February, 230 items should be completed. By the month of March, 180 items should be completed. By the month of April, 130 items should be completed. When I say should be completed, this is the expected one. Now let's see what actual team did. Team did well here, better here, and here slightly not good. Again, they came down closer to the finish line. So it was fluctuating. Okay, this is how the team will work. This is a planned one, and this is the actual one. Okay, actual is a bit closer. If you see by the month of July, it should have been completed with 80 items. Okay, 80 items only should be remaining, but team is having a little more gap here. There's a gap here. With this, they're going to do forecast. As a leader, like Stephen did the forecast, they'll do the forecast. They'll start putting a dot from here. Okay, if the team is working in this particular speed, the team will not complete in the month of October, but the team will complete in the middle of November. So we're getting a gap of nearly a month, right? So this is what forecasting is all about. Forecasting is based on the current situation, you will be able to tell what will be the future. And based on that, your project plannings will get altered. And this is very crucial for a manager. And this is what I'm talking about, forecasting. Okay, yeah, there is schedule forecast. Schedule updates or forecasts of estimates or predictions of conditions is very important. Predictions, you'll be able to predict it. Okay, something you can see the future in our head. Maybe you remember it on the first day I was saying that a leader is a person who can see something which others cannot see. So leader is a person who can see something different, something new which others cannot see. When we see that, that's a starting day of our leadership journey, right? That's about the part of scheduling. Cool. Okay, we had a journey about schedule. What we'll do here is we'll see a couple of questions for the day, and let's get some understanding on that. So Stephen and Eric, help me with the question number 1.
Oh God, here we go. Here we go. Let's see. It still makes the project to complete before the regulation. Oh, I know this one.
Oh, really?
I know it.
Mm-hmm.
I'm going with A.
A, critical
Yeah, that's
path.
what I was going with too.
Okay. So the question, the last sentence says that she confirms this by analyzing the sequence of activities with the least amount of scheduling flexibility, right? And I believe you both cracked it.
by the keyword here is least amount of.
Yep, least amount of scheduling flexibility.
So that happens here in.
Yep, critical path.
Critical path method. Amazing, amazing. I'm happy you guys are cracking it. Okay. I would request you, when you go for the real examination, when you read a paragraph like this, be watchful on some keywords. And when you say least amount, yeah, it is going to be critical path talks about 0 as a float. So we have to keep watchful on the particular keywords. Great. Let's go to the second question.
Oh. B.
Okay. Okay. What is the keyword you see in the question to go for the answer B?
Designing help ensure the dependencies when required to defined. Designing several. I kind of keyed off of the deliverables. The deliverable, I keyed off deliverables, and actually I may have read too much into it. I was thinking deliverables may have been coming from like an external vendor.
Could be, but also one keyword here. Yeah, you are close to the answer, but one keyword here I'll say must be complete before manufacturing can begin. Must is a keyword. When it's a must is a keyword, what kind
C, actually. Is it C?
Yeah.
Yeah, must be complete. Yep, mandatory.
Yeah, we were talking about some dependency of mandatory, discretionary, external, right? These three are dependencies, out of which C could be the answer because it's a must. Must means it makes it mandatory, right? You cracked a sentence where the keyword is, but still you could go a little more closer to C must as a keyword.
Must be complete. Yeah.
Yeah. Okay. Watch for the next question.
Bar charts. Bar charts. Logical relationship.
I'm gonna take just a guess here because some of the other answers don't make any sense to me, but I'd go with D.
D is where I was. D is my first choice. I was trying to figure out what exactly.
You guys are correct on that.
Yeah.
Yes, it's perfect on that. Yes, D is right.
Yeah.
See, they're asking illustration of data, the representation of data by bar chart, which will be good for you. Always a progress of a project or status can be well represented by in the bar chart rather than network diagram. Network diagram is good for critical path, logical relationship, resource trade-offs. This all can be done with a network diagram. Where it comes to the bar chart, which is good for progress, you show the progress, isn't it? Month of January achieved 80%. A month of February achieved on 25%. It'll be a bar chart there. So your guess is absolutely right. Amazing. You guys are ready. I think you both are ready for the exam already.
Oh, now that they've got that math crap in there. Yeah.
Okay, here is it. By the way, when you come back to the video again, please read through these explanations to understand how the answer came up, right? Let me not eat your time now. So we will go to the next couple of 3 questions and then we say thanks for the day.
What?
what you will tell her about the milestones. The question is, what is a milestone, or what is the duration of the milestone?
A milestone doesn't have any duration. It's the achievement of
you rocked it. You rocked it. Absolutely, absolutely, you're right. I was talking about a Toyota has 1,000,000 car to be sold, but there won't be any particular day for it. They will tell that we have a milestone of achieving 1,000,000 cars sold in United States.
Makes sense. It makes sense.
Right, that's how they make it. But again, I'll warn you on that. There are some organizations who set date for the milestones also. From PMP perspective, there is zero duration. Perfectly, you guys are right. Amazing.
Yeah, milestone is a destination, not
Exactly.
is a destination. Okay, that makes sense now. That makes sense.
Yeah. Let's go to the next one.
Standard deviation risk. There's no relationship. I don't think there is a relationship between risk and deviation. I'm going to go with A.
Okay. But generally, standard deviation talks about what is the possibility of both the side.
Yeah, I would say B.
D. Okay.
Or I'm sorry. Well, if I'm thinking about what standard deviation actually is, I would change my answer to C. Sorry.
Can you repeat again, Eric?
But
Can you repeat that?
it's just a guess.
Guessing what?
What'd you say? I'm sorry.
You're guessing what is the answer?
C. I'm changing my answer to C.
Oh man, today you are clicking hard. That's perfect.
How uncertain the estimate is?
I'll come back. I'll explain to Stephen on this.
I don't understand that one.
Real quick. Real quick, Stephen, the way that I'm going to associate it's a little off, but when he was talking about standard deviation and you were talking about the way that you can estimate projects just by looking at them, your standard deviation on the project that you gave the estimate to was pretty accurate. So the further you deviate from that estimate, that'll give you the window of how sure or unsure you are about the estimate.
Yep.
Your standard deviation on your projects would probably be really low because when you estimate a project, it probably comes pretty close to that every time you complete it. That's how I came to that conclusion.
Okay.
Yeah.
Okay.
Maybe the English sentence put over here maybe slightly twist your thought, but what Eric explained is absolutely correct. Thanks, Eric. It was a good explanation. To make a little more clarity for Stephen, which of the following best describes the relationship between standard deviation and risk? The moment we see the word relationship, we feel, what's the relationship there, right? But standard deviation could be something like this. It could be plus or minus 14 days in a project, in a particular activity. Now, that shows how uncertain the estimates are. When it is uncertain, the risk is higher. You cannot commit to your stakeholders, this is how the day I'm going to deliver you. It will be a little uncertain in between this timeline. So that's the relationship they're talking about between standard deviation and risk. The standard deviation brings risk. Could be of either lower side or there can be higher side. So how uncertain it is, with the word you see uncertain, it is nothing but risk, right? This is what we're trying to map. Hope you got a little bit there. We will move to the next question.
Flow of an activity determined by.
That would be D, right?
I'm thinking that one's D.
Oh, you both rocked. My God. How you got that?
Well, because the float is gonna be the determining time that you can delay something.
Fantastic. Without delaying the critical path. Amazing, amazing. I'm totally impressed. Really great. Super, that's great. And we are to the answer. Yes, the float of an activity is the length of a time. The activity can be delayed without delaying the critical path.
I was going to say, I was really confused at how that couldn't be the right answer. Okay, good.
You got it.
Yeah,
got right
okay,
answer.
good.
Yeah, that's what I'm saying. Okay. Yeah, Stephen, you got the right answer.
All right.
Okay, it's an amazing day for you. Okay, that's really cool. Great. I'm happy that you both are catching up really well, and the depth of understanding is really good from both of you. That's great. So we will call it as a day. I know it's much late for Eric as well. So what we'll do here is, as we are learning through, I would recommend something we can do. I will share this project with you, which we discussed early on. Let's do it as your free time. What we can do is we can work on two factors. One, we learned about scope management. One, we learned about schedule management now. So spend little time with this project. Maybe you can take a screenshot of this in your computer also. What you can do is come out with a work breakdown structure if you are a manager for this bullet train project. I'll repeat the task. Task 1 is come out with a work breakdown structure, that is a WBS, at a higher level for this bullet train project if you are a manager for this project. Okay, that is point 1. And the second point is try putting out a sequence diagram or network of activities. I said activity A, activity B, activity C, something like that. If we can put say 10 items for this bullet train, it will be beneficial. Okay, what I'll tell you here. What we can do is, create work WBS for the project. Right. Manager. Create dual. Okay. Is my explanation clear here where you can start doing something on that? Why am I not fitting here? Okay. So let's try this on your day time for tomorrow. And I know it is not going to be easy. It's slightly tougher, but do at a high level. Imagine I take WBS. WBS is a work breakdown structure. You will tell that the bullet train land acquisition is going to be one task, one particular major task, and putting pillars and laying the track could be other one, and getting out the bullet train, as usual, the bowing the particular compartment as one task, and you go step by step. You'll make a design of it, you make a particular development of it. So you can put a WBS, the breakdown structure, step by step. A network diagram talks about at the activity level. Take one compartment as an work package. A work package can be a compartment. Can be a work package. Under package, create activities. Activities can be anything under the compartment. I don't want to define something and block your brain. you can create a lot of activities under a package. If a compartment is a package, in a compartment you'll have a seats, you have Wi-Fi system, you have lighting system, AC cooling, you have a flooring, lot more, auto opening doors, lot more on that. So put all that on how you're going to happen. Or if you think something different also is fine. Okay, so what you're going to do with this project is you're going to do 2 knowledge areas, that is a scope management, and also you're going to try the schedule management. And why we are doing this is to recall what we learned. Only when you try to implement it, it will stay with you, right? So we will try to implement it as far as you can. That's a goal. Is the goal clear?
I think so.
Fantastic. Any help for you, Eric? Are you clear on that?
Yeah, I'm clear on it.
Okay, give an attempt. Even if it doesn't come well, don't worry, but give a try. So when you come tomorrow, we will have a photo click of what it is, then we'll take it on. Before that, what I do is I'll help you to get the WhatsApp group, so that will be easy for us to work it out. So
Is there a way you can screenshot that and send it to me?
yeah, I just did a screenshot. You will get it now.
Okay, perfect.
So I'm going to do that. Don't worry. I'm going to do that. And what I want next is I want numbers so that I can create a WhatsApp group so I can share the details with you. So
Here we go.
we'll take in this part. Where we'll do, it should be in our chat. But Stephen, you ought to download the WhatsApp.
I downloaded WhatsApp. It's all set up and ready to roll.
Oh man, this is so fast. Okay, that's it. Okay. Wait, come out of it. What's happening? Something's blocking me. Why am I not saying it? Wait. Okay. Okay, here it goes. Okay, I'll take the number from the chat. For some reason, I couldn't get back the screen. Okay, I will handle it. What I'll do is, I think Eric, you two put the number there. I'll create the WhatsApp group, so we'll get in touch. Fine. And thanks for participating. So what we'll do tomorrow, we'll connect again. When we start the discussion, we'll start with a task which we did, and then we'll go for the cost management. So that's a plan for tomorrow. Fine. So any feedback or takeaway for the day? Anything to be addressed? Questions?
I think we're
No,
good.
just need to rewatch some parts of this discussion, definitely.
Okay, yeah, you want to relook at the video again. Is that the one, Eric?
Yeah.
Okay, great. You can do that part. Yeah, sure. And yeah, good. Thanks for participating. Have a great evening. We'll catch up tomorrow again.
All right, thanks.
Sounds good. Thank you. Have a good night.
Thank you. Yeah, good night. Bye-bye.
Hey, Sean. Oh, yeah, got stuck with me. I don't know what's happening. Yeah, yeah, it got stuck. I couldn't stop it. What's showing for you there? Yeah, it got stuck for me. In the last minute, it got stuck. No action on the regular anything. So what happened is, I want to share some screens with this Stephen and Eric. So I've asked them to get into WhatsApp. I want to share some details on their task for them, what need to be done. I've asked on the numbers to be shared. And, okay. Maybe it's my computer issue got stuck, not sure. Only when you close it, it will go for recording computer. No, I couldn't do anything. The mouse is not doing anything here. Let's drop it out. No action from my side. It's all dead. Okay. And is it got recorded now? Is it recorded? By the way, how we are sharing the recording to them? Okay, they're able to see now. Okay. Okay. Okay, because they specifically today wanted, because we had some calculations happened. So Eric wanted me to cut the video and learn it again. Okay, fine. If possible, share the link. I will also take a look on how it's coming out. Okay. It's totally stuck. No, for me, nothing working. It's all stuck there. It says stop share, and if it's stop share, also nothing happens. Now, once it's recorded, where you will see that? Okay, please. Yeah, please do it.